All right. Good morning, everybody. Thank you all for getting up here very early on the very last day of the conference for the exciting topic of billing. I'm glad that you all realize how important it is to actually understand what your business is, what it costs your business to run your software. Lots of people don't understand how important this topic is. Usually they think it's really boring, so I'm glad that you actually understand. My name's Evan Jones. I'm a software engineer at Bluecore, and we're going to talk today about going beyond your bill and getting more detail on cost. So first, we're going to talk a little bit about Bluecore's cost challenges and how I got involved in this. We're then going to talk about Google's existing cost management tools, what they give you out of the box. We're then going to talk about how you can create some of your own data sources when you need more detail on what things are costing you. And then finally, we're going to talk a little bit about some of the lessons that we've learned at Bluecore about this, and we're going to have plenty of time for Q&A because I tend to talk way too quickly. All right, so first, the reason I got involved in this is I started getting all these questions like, hey, why is our bill so high? Why did February cost us $123,000? Or, hey, why did our bill go up? Why does February cost $23,000 more than what January did? Or, what happened on this day? What happened on October 25th to cause our cost to be really high? Just a quick show of hands. Has anybody here had to answer questions like that for your business? All right, great. The rest of you, don't worry, someone in your company will eventually figure out that you do in fact know how to answer these questions because every single organization needs to know the answer to these sorts of questions. Great, so why did we get here? So Bluecore, we are a 6-year-old startup. We do intelligent e-commerce marketing. We've been around for 6 years, based in New York. We now have about 180 employees. Our customers are hundreds of large retailers, so we are a software as a service application. And we sell to customers like Sephora, Express, Tommy Hilfiger, and other brands that I'm sure you would recognize. The company started with the intention of saying that email marketing for e-commerce isn't really being done correctly. The traditional approach is a retailer just sends the same content to every single customer that's ever shopped on their website. And Bluecore started with the intention of we should customize that and provide people information that's actually relevant to them in this email. So as an example of what that looks like, here's an email that we send for Timberland. It says, other popular purchases, and has 3 suggested products at the bottom. The point of this is a message that the marketer at Timberland has configured to send to their customers after they've completed a purchase. And then these products that are shown at the bottom come from our recommendation algorithms. And so these have been customized for the recipient of this email. Maybe it's based on the product that they already purchased or some of the other shopping history that they may have with this retailer. So these types of personalized messages are more effective, but there is a disadvantage. And the disadvantage is this is what our Google Cloud cost bill looks like. In all of the slides in this presentation, I've had to remove the actual dollar values in the y-axis here, so you'll have to apologize. But this is, in fact, our real Google Cloud bill. This is our top-level bill, daily cost starting in January 1st, 2017, through until February of 2019. This is as much data as the built-in Google Cloud Billing Console would give us. Now, because of some of these spikes and variations, it may not be extremely obvious, but this is actually a 3x increase over 2 years. So this is 75% annual growth. Now, for me, this is a great problem to have as an engineer. I love this because this means we've got to go now and figure out how to optimize this and solve this. It also means that our business is growing. So, this is actually a really good problem to have, but we do want to make sure that our growth is in line with our business, or ideally actually grows slower than our actual growth in our business, right, which would improve the profitability of the business. So because this has happened, we've needed to start looking into all of these questions like, okay, so why is our bill so high? Where is that money going? The top-level cost like this doesn't actually show you a whole lot of information besides, hey, you're spending more money than you used to. But I do think it's interesting. There are a few interesting trends you can see here. So at this far left mark here at around November or December of 2017 is Black Friday. We have a very seasonal business. People do a lot of shopping starting between Thanksgiving and the end of the year. And so that spike there is their increase for 2017. We have an extremely large peak there, which is in about October. That was when we went and did load testing for Black Friday. We want to make sure that every year we can handle the load that we're going to see. We go and try to break our own systems. It turns out that costs a little bit of money, so that's what that particular spike is for on that particular day. And then you can see Black Friday 2018. So you can see here for Bluecore, we tend to have this thing where our costs kind of go up, and then they go up a heck of a lot starting in November, and then they kind of stay at that level. And then they go up the next November, and then they kind of stay at that level. Okay. Great. So when we had these questions about cost, when we were smaller with about 10 software engineers, we would just go to the all-hands meeting and be like, hey, where did our cost increase come from? Last Thursday, something must have happened. Our data store cost is up. Our App Engine cost is up, whatever. Did somebody do something? And usually somebody there would be like, oh, yep, I think we turned on this new data feature. Let me go look in to see if that's what's causing the cost increase. We could go find it and solve the problem. Now that we're bigger, we have about 40 or so engineers, that doesn't actually work anymore. We have too many changes and too much complexity. So when we go and ask that question at the all-hands meeting, people are just like, I have no idea. We changed all sorts of things. Maybe one of our customers started using a feature in a new way that changed how our application runs. So we needed to go and do something to answer these questions. So cloud providers like Google provide you this nice advantage. There's really, really clear pricing. Go look at the price sheet to go see what something costs you. And they provide you this nice detailed bill at the every single day to tell you what you actually used and what things cost. Before I started at Bluecore, I came from an organization that owned its own servers, and so I kind of assumed that this would not be a problem in the cloud universe because you have this nice detailed bill. You want to know what something costs? Just look at your bill. It turns out that that is true for things that are separate. So for example, if you have fairly separable applications and you can have, say, a separate Google Cloud project for your team or for your feature, Google's built-in bill probably will give you the level of detail you need. It will tell you, hey, this team cost this much, here's all the line items that this team actually used, and that may actually be sufficient. So if that works for you, that's great. But there are things that have to be shared. In our case, Bluecore is a software as a service application, so at least at some sort of high-level, logical level, we have one application that is used by all of our customers. And then the next line here is events. So you can see for Bluecore, those are really the two big cost drivers. It's ingesting data onto our platform, which is events, and then sending emails, which is email. There's a bunch of these other teams and other line items at the bottom. From a cost optimization perspective, we can kind of ignore them because they're a small part of our bill. Here's a table that was created by somebody on our finance team using this data. Again, I can't actually show you any of the data, so this is just the column headers off of this table. This is showing the 25 lowest margin customers, and I really love this table. It shows the brand name, the monthly recurring revenue for last month, the total email and event cost, and then a computed margin, that is an email and event margin, that is how profitable or unprofitable it is, as well as a total email sends. The thing I love about this table is that our finance team created this without the engineering team doing anything. All we've done is we've provided this cost per customer with this email and event cost, and they combined it with the existing data about how much revenue we're getting per customer to produce this table. And this table has been super useful because we go and look at this and be like, hey, why is customer X costing us so much? That's really weird. And then inevitably when that happens, we go and look at it and it turns out there's some sort of configuration issue, or they're using some particular weird part of the product in a way that we didn't expect, and we can go and actually fix that and actually improve these problems. So this has been super, super helpful. And again, the part I love is the engineering team had nothing to do with this. The finance team actually created this themselves. So this is just an example of the kind of things that you can do once you actually instrument your bill to the level of detail that you need. All right, let's talk about how we can actually do this. First, let's talk about the existing cost management tools that Google provides. The first thing that you really should look at, or certainly I look at for any cost problem, is the Google Cloud billing reports. Bluecore has been a Google Cloud customer for long enough that this billing report did not used to exist. It does now exist. It's actually useful. If you haven't played with it, you should. It looks like this screenshot shown here on the right. It will show you your cost per project, per service, per line item or SKU, sliced over different time ranges. It lets you slice and dice this how you want. It's pretty useful. The part that is still unfortunate, though, is that there are things like this big blue bar here at the top that it can't provide you any more detail than the line item and project level. So why is this big blue bar so high? We're going to have to go do some work to figure that out. So the first step to figuring out why the heck this single line item is so large is to get the actual raw data. This is where the billing export comes in. This lets you get your detailed cost data exported directly to BigQuery. There's also a JSON export. I don't find that to be as useful. If there's one thing that you take away from this, you should go turn this feature on today. The reason is you can't go back in time and get the detailed billing data for data in the past. So if you are going to want to do cost analysis at some point in the next, say, year, and are going to want to look back at cost data from today, you need to go turn this on today. It probably won't cost you anything if you're not using BigQuery very much anyway. What it gives you is it gives you this sort of detailed data that's shown on the right. We're going to talk a little bit about it in a moment, about the actual Google Cloud bill. And there's some sort of schema for this. There's lots of documentation. OK, so what do you get when you actually if you're actually working with this data, how should you actually work with it? A few tips that are useful to know. First thing is Google bills you. Google's official billing time is Pacific time days, so Mountain View Standard Time. You can convert the billing data into this time zone by using this BigQuery function here, timestamp trunk, take the usage start time and convert it into this America Los Angeles time zone. Now you'll get days that are the same days that Google actually uses, which is useful when you want to compare this to your bill. Some of the data is delayed. It's a small percentage. It keeps decreasing. Last I looked before making this talk in February, it was something like 0.1%. Usually that data is delayed only by a day or two. Sometimes it's a little bit more, but not much. The point here is if you want to use this data, you're going to have to process chunks of time or reprocess it or delay your processing a little bit to make sure that you actually capture all of it. Tax and corrections show up much later. Tax shows up at the end of the month. If you have corrections or credits, they will show up way later. This can also screw up your analysis, so you may end up having to, again, reprocess this data multiple times to sort of get the correct view. And the other thing is this schema has human descriptions in it. It has a SKU.description and a project.description, or excuse me, a product.description. And these can change. The most recent change was Google changed this from calling it standard instance CPU and standard instance RAM to predefined instance CPU and RAM. This is totally fine if you're doing some ad hoc analysis and just looking at what was the cost last week. If you're trying to do some analysis over, say, a year, you're going to want to use the ID fields that Google provides. And now the problem is that those aren't human understandable. OK, what does this actually look like? So let's go and recreate this graph from the Google billing report. This is showing us the top SKUs by day this month. These are their top Google Cloud billing line items for the current month, broken down each day. So that was what the screenshot was that we showed before on the left-hand side. And on the right-hand side is the sort of BigQuery results that we want, which have the day as well as then the actual line item here, like the front-end instance, data store, cloud data store read operations. What does this look like? Here's the example query. You don't have to understand it. I am going to walk through a couple of the parts that are somewhat important to give you a sense about what the actual raw Google billing data looks like. The first thing here is this day. This is this magic conversion to Google standard billing days. So timestamp trunk, the you should start time to this America Los Angeles time zone. Again, we want to actually go and compare to our actual Google Cloud bill. You're going to want to convert to that day if you want to be able to do that. This SKU description, this is this human readable description of that line item. And then we want to sum our cost. And this sort of magic expression here with this coalesce unnest thing is BigQuery magic to say, hey, take the credits that are attached to that line item and just sum them all up as well. So when you have credits like, say, the sustained usage discount in Compute Engine, there can be multiple credits attached to a single line item. We want to add all of those credits together to get the actual cost after the credits have been applied. We want to take the sum of days since the beginning of the month, so that's this timestamp trunk to the month and this partition time magic. Again, you don't have to understand this. And then we want to sum all these things together. The final result is going to look something like this. This is Bluecore's actual top line items for March 16th. Front-end instances, that's App Engine CPU. Google Cloud Data Store read operations. Back-end instances, that's also App Engine CPU. And then BigQuery flat rate annual. We're a big BigQuery user, so we pay for flat rate pricing. Great. So now we've just recreated what the billing report already gives us. So who cares? What's the point? Well, the point is we can now actually go and do additional analysis. And one of the things that you might want to do if you're a little bit crazy is actually go reproduce your exact invoice. Now this sounds a little silly, and I admit it is. It doesn't serve a whole lot of practical purpose, but it is very useful to be able to verify that whatever conversions or analysis you're doing is actually correct by matching your Google Cloud bill. If you want to do this craziness, Google provides you some tools to make it actually easy. First is provides this invoice.month field, which gives you a year and month string, which is exactly which invoice that particular record is going to end up on from Google's bill. So you can group by that. The second thing you're going to want to do is you need to round your cost and credits to 2 decimal places at the line item or the SKU level. So this is this round to 2 decimal points BigQuery expression there. Finally, the export data will show tax as one line item at the beginning of the next month, whereas if you look at your PDF bill, it will actually show you your tax on separate projects. So if you're comparing your PDF bill to your BigQuery results and really want it to add up, you're going to have to do a little bit of math. And if you do this, you actually get exactly to your bill, down to the exact penny, since December 2018. There's a document in Google's billing documentation which will show you some exact query examples. Again, is this actually that useful? It's useful for debugging things, but for the most part, if you don't do this, you're going to get within the nearest dollar anyway, so you don't necessarily have to do this unless you're like me and are kind of anal retentive and want to really make sure that you got it right. Okay, so now what can we do with this? We have our raw billing data export into BigQuery. We now want to actually go and look at it and be able to produce some reports. I suggest that you use Data Studio. Again, it's built into Google Cloud. It's available for you for free. This is not a talk about Data Studio. I'm not going to tell you how to use it or show it to you. There's lots of other talks and resources about this. Again, the billing documentation itself provides some examples. But the point here is you can now create custom dashboards from this billing data. The reason this is useful is that there sometimes are things in the built-in Google billing tool that you may want to come back to multiple times. Like maybe you want to look at, here's the top cost for our production project combined with some cost for some of our top line items in a separate chart. You can create a dashboard in Data Studio just by pointing and clicking, save that as a link, share it with others, look at it every single day. So again, this is still the same data that's available in that billing report thing, but now you can customize it to look at stuff that is actually relevant to you and make that easier. I also just find Data Studio to be a useful tool to know about if you need to do some ad hoc visualization of BigQuery stuff or other data sources anyway, so it's useful to play with. Okay, so this is basically the built-in Google Cloud billing tools. So now let's talk about what other data sources we might want to use to get more detail on this. So as a reminder, the point here is we have these big line items that are left. So for example, this big blue bar, what the heck is in this thing? We'd like to know more detail about where that's coming from. So there are other data sources about what you're using on Google Cloud that you can go and pull some of this from. As some examples, on App Engine, you have request logs that tell you every request that came into your application. For BigQuery, there are query logs that tell you about every query that got executed. For PubSub, there are Stackdriver metrics that tell you about the total bytes going into and out of your topics. For Kubernetes storage and compute, there are usage exports that will tell you various granularities of usage data about those things. And so we can go and combine these existing usage data things with our bill to find out what are in those big line items. So here's the plan. We're going to get the usage per day for one of these large line items that we want to understand in more detail. We're then going to combine that information with our official bill to get like a usage metric per dollar. And then we're going to produce an annotated bill that has that original data from Google, but broken out into these separate categories with this additional annotation. So the exact way you do this is going to depend a little bit on the resource that you want to break down. I'm going to talk through what we did for App Engine CPU, just because that is, for Google, this is the largest line item, or for us, Siri, for Bluecore, the largest line item that we have. The largest line item we have currently is App Engine front-end instances, which is CPU time on App Engine. We started 5 or 6 years ago as an App Engine application. It's still our biggest line item today. So how do we do this? App Engine has these request logs, and they look like this. You do not need to understand what is on this slide, but the point is there's a whole lot of data in this existing request log. And when we were looking at this, we noticed, hey, there's this line item here that says megacycles 29. What the heck is that? If you look at App Engine's documentation, it says something like, this is a suggestion of how much CPU is used by this request, but it's actually not very accurate. You know, user be warned. So we wanted to know, okay, well, this says it may or may not be accurate. What can we do with it? So we went to Data Studio and produced a visualization of our total App Engine cost at the top. So this is the data from the Google Cloud billing export per day for this one line item. And then we went and summed this megacycles value out of the App Engine request logs over that same time period. And so what do you see when you see these two graphs? To me, that's pretty damn close. If you look at these two blobs here, you'll notice that they're not actually completely identical. There's a little bit of difference between these two things, but that's pretty close. So fine, maybe there's some error here. Maybe we're off by 1%, maybe we're off by 5%. I'm not sure, but this seems like this is probably a useful data source for us. And in some experimentation that we've done by fixing some things, we've sort of verified that it is close. So now what do we do? Well, what we can do is sum the megacycles per day out of this App Engine log to get a total. And then we can compute what the cost per megacycle per day was. So, 10,000 megacycles per dollar, something like this. Now we can actually compute the cost for each request because each request has this megacycles value on it, and we can aggregate these URL paths by team and by customer to break down the annotation to get that level of detail that we want. There's going to be some stuff left over, and in our case, we just account this to unknown because we're not going to get 100% of our coverage, and again, that's okay. That's one of the points here is we don't need this to be completely 100% accurate. We just need it to be like 90% accurate or 95% accurate. So what does this look like? Well, we end up, sorry, the next part I should point out is this is actually a relative cost. I don't actually know how much does a megacycle cost you? I don't know. Google doesn't tell us. It doesn't really make sense. But as a relative usage, a fraction of our usage of App Engine resources, it's a useful measure. And there's lots of other resources that sort of look like this as well, where you can say, well, this is a percentage of our cost for this day, and you can break it out that way. So what this looks like is this produces a table that has, say, each day. In this case, this is March 18th, a URL path or a URL prefix, and then a cost that it cost us for that particular URL prefix. So when we've gone and done this for Bluecore's bill, our App Engine CPU annotation gets us about 38% of our bill. We get that sort of team customer breakdown for 38% from that. We've also had to go and do this annotation for BigQuery queries. Like I said, that was our number 4 line item. So we do the sort of same thing by looking at the BigQuery query log. And we've also done this for data store storage by looking at this data store storage export data or usage data that we then export out of data store. When we do it for these 3 line items, we now have 49% of our bill that's left where we don't have this team and customer level of detail. So this isn't quite good enough. We got 51%, but we still need to know what's in some of this 49% before we know that we have an accurate enough estimate of our costs per team or per customer. So what can we do now? We're going to have to go instrument our code to get more detail about what's in that remaining bucket. So here's our plan. We're going to go and instrument our code. We're going to go and instrument our application in some way. We're going to emit that data. In our case, we emit it in logs, which then end up in BigQuery through the Stackdriver logging export. And then we're going to go aggregate this usage data by day, which will then look like what we did before with Google's own data sources. We're going to get some amount of usage for these additional line items on a daily basis, which we can then combine with the bill. So as an example, we did this for data store gets and puts. Like I said, we're an App Engine application. This is another large line item for us. It was the original sort of storage layer for App Engine. And the way you get charged for it is you get charged for every get you do and every put you do against this operation. So we want to count how many we have. So we have to go and wrap in our application all the get and put calls to count how many actually happened. We then log the counts at the end of each web request so that we can find out for that particular request how many did we actually do. And then we aggregate these in BigQuery using its like JSON extract function, which lets you pull fields out of JSON payloads. So the log that we emit looks something like this, where we have a counts section with the various counts we care about. In this case, this is data store gets and data store puts. And then we also attach this namespace thing. So this is from our application. We have a concept of a namespace, which basically maps to the customer. And so this is why we actually do this on a per request basis, is so that we can get back down to that level of granularity of a single customer. And then we can run BigQuery queries across our logs to basically sum these up and aggregate those together. So what does this look like? Well, now we can get a table that looks something like this, where we produce for a single day and a URL path or prefix how many gets and puts we did. These are absolute costs. Google tells us how much these actually cost, so now these just translate directly into dollars. So this is actually a little bit easier than the case where you only have a relative cost metric where you have sort of a fraction of usage. This one, we can just basically do the math and say, great, this URL prefix cost this much because of our, the price from Google. So here's an example. Here's what our actual detailed cost schema looks like. This is the sort of final output of all of these series of jobs that we've done. This may or may not be the ideal schema. It's worked for us. Hopefully you can use it for some inspiration. If you come up with a better one, please tell me. I'd love to know. So what does this look like? First here, the first most important field is this usage day specific. This matches Google's billing days. So this is this Mountain View Standard Time day from our bill. The next fields we pull out are the project, service, and SKU, or line item. These are the dimensions from the billing exports. These are fields that we group by from Google's original billing data. We then pull out the cost, usage amount, and credits. These are the metrics from Google's billing data, so we sum these out of Google's existing bill. The cost is the actual cost. Usage amount is some per service metric. So for data store, it'll be read operations. For Google Cloud Storage, it'll be gigabyte seconds or something like this. And then credits are the credit value. And the key part that we've done is we have 2 additional custom dimensions that we've added. So we, again, have this namespace, which for us is effectively a customer, and this cost category, which is basically a software component, which we can then map back to a particular team. And the point that we try to, the constraint that we try to continue to make sure we meet here is that if we sum this table on some of these dimensions, that it adds up back to Google's bill. So we're adding these custom dimensions as additional detail again on the bill. So how do we actually produce this? So we get some original billing data. So as an example, we have a particular day, March 18th, a particular, it'll actually be a project and a SKU, but for simplicity, I'm just showing the SKU here, data store gets, and we have some sort of cost for this. So it cost us $2,000 on that day. We then have instrumented our application to produce this usage data of showing for that day, some URL path did 2,400 gets, some URL path did 29,000 gets. And again, we can translate that back to cost. So we can combine these 2 things to produce this annotated bill, which now has 3 line items. So it has 1 data store gets for, say, team A. We have some mapping from these URL paths back to these cost categories or teams. And how much that actually cost. We have data store gets for team B. And then again, there's going to be some left over. We don't annotate, we don't instrument every single application that we run. We just try to instrument the big users. And so there's some left over. In this case, say $363. And again, that's OK. We don't need to be perfect. We just need to get most of it in order to be able to make the right optimization decisions. So now that we've done this, we managed to cover 51% of our bill just by using Google's built-in other usage data sources. So we were able to get 51% of our bill down to this team and customer level without necessarily going instrumenting our application. And at Bluecore, we've then gone and instrumented a couple of data sources. So data store reads and writes is one example. There's a couple of others that we've done as well. That gets us like another 24% of our total bill down to this cost category and customer level. There's going to be some left over. In our case, it's currently about 25%. And in our case, this percentage continues to grow. This remaining bucket continues to grow over time. And our approach has been, once it gets too large, we go and look at it and figure out what do we have to instrument next? What usage data can we import next? And the point, again, here is you don't have to be perfect about it. We just need to get it right enough and get enough of the data correct. And for us, this is sort of accurate enough. Great. So now let's talk a little bit about some of the lessons that we've learned through going and doing this. The first one is you really want to break costs down to teams because that is what actually makes metrics actionable, is when you can get the responsibility down to a small enough pool of people. What is small enough? It's kind of going to depend on your organization. But in Bluecore's case, when it was 40 engineers and we said, hey, data store costs went up last week, that was too large. Everyone just sort of looked around and been like, it wasn't my problem. You need to get it down to a small enough group of people so that when you can say that to someone, they're like, oh, actually, we did something last week. Maybe we should look at this. As an example, here's a cost for one line item over 24 days. This starts at 0. It goes up to question mark number. And when I look at this, I say, maybe something happened there at the end. I don't know. There's a lot of variation. So this is what our bill looked like. I can't remember. I think this was in January. Here is that same line item if we look at just the responsibility for one team, for one cost category. Again, this starts at 0. This is the same 24 days. And you can now tell, holy crap, this went up by a factor of 2 for this particular team. Maybe we should go and look at this. Sure enough, we went to look at it. Here's that same team SKU over 46 days. We went and fixed the problem. The cost went back down to normal after this. So this is just an example of you need to get the metrics to the level of granularity that work for your organization so that you can go and look at something and say, hey, there's definitely something wrong here. It's definitely in this particular part of our product or our software. Let's go and fix the problem. This actually leads to another interesting part is in the cloud, when you are using a lot of these automatic scaling features, performance bugs actually become cost bugs. And I think this is actually great. This is actually an improvement. In the old world, when you had a performance problem where your load went up, there was some sort of error, retrying, or customer load happened, your service just went down. So you knew about the problem right away, but it also meant that your application was broken and your service was broken. if you're using a lot of these auto-scaling things, your service is just going to continue to work. It just might cost you a heck of a lot. So you do need to keep an eye on these sorts of things to be able to find these problems before they cost you a lot of money. There are built-in Google features for this, by the way. There are billing alerts that you can set on various levels of granularity. There are all sorts of other things you can do. Finally, my big point is, again, make metrics that matter for your team. What has worked for Bluecore may or may not work for you and your team, but the data is there. You can go and do it. You can break it down to the level of granularity you want. It is possible to go and annotate this stuff to figure out where your usage is going. You just have to go do a little bit of work, and it's not actually that hard. To learn more today, there's a couple of other sessions still left. 1020, there's automated cost optimizations on GCP. 115, there's aligning cloud costs with service delivery. You can go to the cost management showcase and talk to some of the Google PMs who are working on these sorts of things. And if you have questions about it, there's the Ask the Expert booth. And definitely go and look at the cost management documentation on Google Cloud. On cloud.google.com. It has details about all of this stuff that I talked about today, like how to set up and use the billing export. What does the schema actually mean? And again, because I talked too quickly, I've got lots of time for questions. So if you have any questions, I'm happy to answer them right now. Please come up to one of the microphones so that they can actually hear you. I'm happy to take any questions. And we're just all going to stand here awkwardly for a while until somebody gets brave enough. All right, we have a taker.
Hi, good presentation.
Thanks.
What about the use of labels? Did you find useful? Because GCP doesn't have labels for all the products, right?
Yeah. Great.
Have you made use of labels anywhere?
Great. So what about labels? Labels are actually not very useful for Bluecore because we basically use App Engine and then we use Kubernetes. And so the labels themselves aren't actually very useful for us because it doesn't provide us the right level of granularity. We really need to know, great, how much Kubernetes resources is this pod and all of its replicas using on Kubernetes Engine? What is this piece of software using as a fraction of API requests against some of the Google managed services? The labels aren't actually providing us that level of detail. If what you're using is compute engine VMs, the labels are great, and they show up directly in that detailed billing export. And so if you do label VMs with the right things for your resources, they're going to show up automatically in your billing export. I wish we got that level of granularity for API calls and for other things. I may have heard a rumor that that is a feature request that lots of people have asked for, but it certainly does not exist today. Any other questions? All right, if you do have any other questions, I'm going to stand out here in this room or in the hall. Thank you so much.
Another dimension. All right. Hello, everyone. Welcome to CST 301, Automating Cost Optimizations on GCP. Who likes to save money on their GCP bill? Hands up. Yes, awesome. Good, you're in the right place. So what we're going to do today is help give you some tools, frameworks, ideas to help put you on that path. I'm Philip Coletti. I'm a product manager on the cost management team here at GCP, so I have the kind of cool job of helping you all save money. Presenting alongside me today is Yuri Grinstein. He's a customer engineer based here in San Francisco. I'm actually up in Seattle. And I have the easy job of teeing up Yuri. He has the admirable and risky job of running some non-trivial live demos, and hopefully those will go well. Quick public service announcement. We are going to do some Q&A at the end. This is probably old hat by now, but you can add questions to that Q&A inside your Cloud Next app in this session. So as questions pop into your head, put them in there, or if you see other ones that you think are good, feel free to upvote those, and we'll try to get to them. So as I said, today's about saving money. We're going to highlight some examples of how you might see resource waste in your cloud. And then we're going to show how to automate both the identification of the resource waste and how to go clean that resource waste up so that you can capture savings. So you actually have something practical to take away. It's worth mentioning there's a bunch of other ways you might think about saving money on GCP, ranging from like more efficient selection of services to actually reducing and restricting the resources that people can consume, to selecting different pricing models like committed use discounts, stuff like that. We're not going to cover those today, but you can see other sessions that we've recorded. CST 100, making your dollar go further on GCP. CMP 208 is saving even more money on Compute Engine. And CST 201 was about financial governance on GCP. Those are just a few of the examples. We'll post all the sessions live afterwards at cloud.google.com/cost-management. Okay. We've covered some of these slides in a few other cost management sessions, but I want to take a second to highlight how optimizing costs on GCP and cleaning up resource waste on GCP differs from what you might have experienced in a traditional data center. So, because reducing resource waste is not a new problem. We still wanted to do this in a traditional data center, but the immediacy and the impact of it has changed when we moved to cloud. So let's imagine that this is the resource usage for our business, a bit cartoonish, but illustrative for our purposes. We're growing overall up and to the right, and we have some seasonal fluctuations with our business. But in reality, we're not utilizing all of the resources that we're using. Not everything that we've provisioned is actually doing valuable work for us. So the green line here represents the resources that we're actually utilizing, and all the gaps in between that is wasted resources that aren't doing valuable work for our business. Now, back in our data center, we had to procure hardware and software licenses. So when we reduce our resources that we're consuming down to what we're actually utilizing, we don't necessarily save money. But what we do is free up capacity for other teams to go use those things. And additionally, if we save enough of that waste, then we might actually be able to save having to buy more servers, storage appliances, et cetera. And then we can capture some of that money as savings. But it's definitely not everything that we've captured as far as wasted resources. Fast forward to cloud. Right now, when we have a VM and we go shut it down or we downsize it, we can immediately capture that as savings. So the impact and the immediacy is much more direct. It goes straight to our bottom line. And this is not a hypothetical problem. It's not an abstract idea. A recent RightScale study found that 35% of actual cloud spend from customers is wasted when measured, and that's actually higher than what the customers themselves guessed. They tended to peg it at about 27%. So let's take a second. Let's unpack what we mean by wasted resources. I'm just using this to refer to resources that we've provisioned that aren't doing valuable work for our business. And I like to think of these in three broad buckets. The first is over-provisioned resources. The canonical example here would be something like virtual machine downsizing. So I've provisioned a VM, say an N1 standard 32, but in reality that's way more cores and RAM than I need, so I could take that down and make it an N1 standard 8, something like that. And we actually provide these recommendations today in the Compute Engine console. You'll see a little light bulb that says, save $33 by making this VM an N1 standard 16 instead of 32 or something. And I don't know the exact prices, so don't quote me on that. The second category is idle resources. So rather than just being too big for the workload, some resources might actually be completely unused. A classic example of this would be orphaned persistent disks. So I have a PD HDD that was attached to a VM at one point, and that VM got shut down, but the disk still exists, still costs me money. I am neither reading from it nor writing to it, so it's doing nothing useful for me. And the last example would be part-time idle resources. Here we might have a resource that is used quite heavily at some times and is completely unused at other times on a predictable schedule. So for instance, I have some VMs that are basically on a working schedule, 9 to 5 on weekdays, and then they aren't being used on nights and weekends. And at this point, I actually would love to get you guys involved a little bit more. I want you to think for about 60 seconds about examples of waste that you've seen in your environments, or even examples that you've heard of in your environments, or ones you have a sneaking suspicion might be there even if you haven't seen them in the wild. So turn to your neighbor, preferably one that you don't work with on a daily basis, and see if you can come up with 1 to 3 examples of resource waste, maybe in these 3 buckets, maybe in a bucket I don't have here, and then I'm actually going to call on a few people to get some examples just to get the creative juices flowing. So do that, break. All right. If you can hear my voice, clap once. Yeah? Awesome. So I heard a lot of good conversation, which is exciting. If we have a few brave people who'd be willing to volunteer what they talked about, raise your hands. Overuse of SSDs. All right, we have at least one fan. Cool. You, sir. Say that one more time. Public IP not released. Yeah? Okay. Another clap. Go for it. Cloud storage where the files are not accessed more than once. Sir?
You could provision a VM with something like a GPU, but not be using that GPU and only using the CPU.
Okay. You could provision a VM with a GPU and not actually be using the GPU, just the CPU. Is that right?
Yeah.
Okay. Excellent. One more. Writing logs to storage and never cleaning them? Excellent, yeah. Okay, so these are a couple great examples. We are going to talk about a few examples today and do some deep dives on how we might go about totally automating, identifying, and cleaning them up. But I just wanted to kind of do this broad look first so that we all have an idea of like what the things are that we might go look like had we more time today. But before we do that, one last thing I want to talk about is automation. Why is it important? Let's take the example of VM right-sizing recommendations, which exist today, as I said, in the GCE console. We provide these recommendations. You can go click into your compute console and see the little light bulbs, click on them, evaluate them, apply them. And if you have one project, that works really well, right? Just scan through 20 VMs, see which recommendations you have, click on a few, apply a few. Works pretty well. What if you have 15, 20 projects? Maybe you might click through those, but it's starting to get pretty tedious and annoying. What if you have 100 projects, 1,000 projects, with tens of thousands of VMs? This is totally realistic for some of our larger customers. At this scale, clicking through consoles, individually evaluating these breaks down and doesn't work, especially for a single central administrative team. So we need a way to automate this to get a little more leverage and a little more scale. So I'm happy to be able to tell you that this particular recommendation, the VM right-sizing recommendations, is now available through an API, which is an alpha. So you can go to a single place, hit that API, pull all of the recommendations for all of your projects, and then put them in a dashboard, send them out to the resource owners, and do whatever you need to delegate that responsibility and figure out how to go save that money. But now we're actually going to go look at a few other examples of resource waste. And we're going to do this through some end-to-end demos, and at this point, I'll hand it off to Yuri.
Hi, everybody. So my name is Yuri. I'm a customer engineer here at Google Cloud, which means that it's my job to actually work with customers every day. And today I'm going to walk you through a few examples where we'll actually take a look at some specific examples of waste. And the framework we'll generally use is, first, we'll identify the waste. The second thing we'll do is figure out how to clean it up. And thirdly, we'll look at how we can actually do that in quote-unquote production, how to do that at scale, how to do that in an automated way moving forward. So let's start by talking about reserved external IP addresses, which is actually an example that I think someone called out as an example of waste. So I'm very glad that we have this one covered. The reason why these exist is that they allow you to maintain the same public IP address after you shut down or delete a virtual machine or a load balancer. So the idea is that you can then maintain the same IP address for your customers, for your users. You don't have to reprogram DNS as the underlying resources change. The key thing to remember about these is that they're actually free, as long as you're using them, right? So if an external IP address is attached to a virtual machine or a load balancer, GCP doesn't charge you for using it. However, as soon as you delete the resources that back that IP address, like the virtual machine or the load balancer, we actually charge you an hourly rate, okay? And while the $7.20 per IP address per month doesn't seem like a lot, you know, if you have applications that use a lot of these, if you have applications that do a lot of manipulations of virtual machines, you're creating them, you're deleting them, but you're not actually cleaning up the IP addresses, you're not tightly managing them, over time this can add up to quite a bit of waste. And also for our purposes here, this is a really simple and illustrative example, so this is where we'll start. Okay. So again, the framework we'll use here, if I can get into the, my computer here just to make sure it's awake, is, let's just go back to the slide for 1 second, please. The framework we'll use is, we'll first identify the waste. And to do that, we'll create a cloud function that'll call the Compute Engine API and look for IP addresses that are both not currently in use and have not been so in the last 30 days. And then the same function will basically just delete those addresses. Okay. And then in order to actually run this at scale or in ongoing fashion, we'll use Cloud Scheduler, which is the managed cron task scheduler in GCP, to call this function on a regular basis. So let's take a look. Let's switch to the demo, please, now. So we're starting out in the list of IP addresses. We can see that we've got a couple of here. You can tell that I've named them very cleverly to be able to distinguish them. We have an IP address that is, in fact, in use. It is attached to a compute instance. And then we have another one that is, in fact, not in use. And it's very clearly labeled, so it's telling us that there are no users for it. And also, the console is kind enough to let us know that this IP address will, in fact, start to incur charges because it's not being used. Right? So now we need a way to automate the detection of this in our project. And to do that, we'll use the Compute Engine API. So I'm going to use Postman as a way to kind of show you what the API responses look like when they come back. So this first one is I'm going to go and query the IP addresses in the project, and they come back with a list. So here, the first one is my used IP. Right? You can see I get the name. I get a status field, which tells me that this IP address is in use. And then I also get a users field that and tells me which load balancer or virtual machine is actually using this IP address. We can contrast that with our unused IP address, where the status is set to reserved. Right? So the address is reserved, but it is not actually in use, so very easy to distinguish between the two. And also you can see that within this address, I don't have a users field. So kind of two indicators that this is actually not being used for anything. So now we have a way that whereby using the API, we can find those IP addresses that are not being used for anything. And now we need to actually go ahead and do this. And to do that, I'm going to switch to my code. So this is the code that I've written for Cloud Functions. This is using the Node.js runtime. Okay, let's make this a little bit bigger. And I'm going to just walk you through the code. It's pretty straightforward. We're first going to use the getAddresses method to get all of the addresses in our project across all regions. We're then going to iterate through those. And for each address, we're going to get its metadata. The first thing we're going to do is to check if the status is reserved. Right? Pretty easy thing to check for. Reserved means, again, the address is reserved, but it's not in use for anything. And if that is in fact the case, we're then going to compute the age of that address to figure out how long has it been around. Right? And the general rule of thumb we're using in this example is, hey, if something's been around for longer than 30 days and it's not been used in the last 30 days, probably a good indicator that we can just go ahead and clean it up. And if that is the case, we simply go ahead and delete the address. So now we have our code. Now we go and create a Cloud function that executes this code. Here's the source for the function. It looks exactly the same as what you just saw me go through. Here's the trigger endpoint for that function. So it's just an HTTP endpoint where I just make a GET request to it and the function executes. And now in Cloud Scheduler, I've created basically a managed cron job that executes this function on a regular basis. I'm using a cron syntax that basically runs it, I think, something like once a week. You can figure out what is the best interval or the right interval for you in your environment. And let's go ahead and see if this actually works. I'm going to go ahead and run it. This shouldn't take very long. And now, if I go to my list of IP addresses and I refresh it, if everything went well, it should theoretically come back and I'm just going to refresh the page. And the IP address, there it is now. Our unused IP address has been deleted. Okay. So that's our first example. Again, just to kind of remind you of what we covered. We looked at using the Compute Engine API to detect IP addresses where the status field is reserved rather than in use, and look at the creation date to calculate their age. We then simply make a call to the delete method to get rid of those. And then we use Cloud Scheduler to schedule the execution of that task on a regular basis. Let's go back to the slides and look at our next example. All right. So the next example we're going to look at are persistent disks, right? So these are durable, high-performance block storage within GCP. They come in two flavors, hard disk drives and solid-state disks, and you can attach them directly to your virtual machines or Kubernetes nodes for local storage. Okay. If the disk is not attached to a virtual machine or a Kubernetes node, it's actually not being used, right? And there's a couple of examples or a couple of reasons why that might be the case. The first one is if you actually just create a disk from scratch, which is an option that GCP allows you to do, right? You just create a disk. And if you do that and then never use it for anything, it just becomes a wasted resource. Another reason may be that the disks don't get deleted when virtual machines get deleted, right? Disks can be configured to auto-delete themselves, but it's possible that the policy is not followed, right? And this could also add up to a non-negligible amount of waste, right? It's 17 cents per gig per month for persistent disks, for for solid-state disks rather, and 4 cents per month per gigabyte for hard disks, right? And if you look at an example where you say you have something like 200 virtual machines, each of them uses a 50 gig disks, and you don't delete those disks and you delete those 200 machines, that's about $20,000 a year that you can actually end up wasting, right? One thing I should say is that another option you could take is to snapshot the disks rather than delete them, so you're still preserving the data that is on those disks in case you need them, in which case you'd pay about $3,100 a month for that snapshot space, still saving yourself about $17,000. Right? So how are we going to automate cleaning up unattached persistent disks? We're going to use a very similar mechanism here. We're going to write a cloud function that'll pull the Compute Engine API for disks. And now we're going to look, instead of just looking for disks that are unattached, we're actually going to look for two different cases. We're going to look for disks that were, one, created without ever having been attached to a virtual machine, in which case we could probably more safely conclude that those are wasted. The other example we're going to look at are disks that at some point were attached to a virtual machine, which might mean that they still have some important data on them, right? And then we're going to automate the deletion of them, again, in the same function. And finally, we're going to use Cloud Scheduler to schedule the execution of this task. All right, so let's go back to the demo and take a look at that. So now I'm going to look at my list of disks. I have 4 disks in this project. You can see that the console here gives me some information that I may be able to use to figure out what's going on. I have 2 disks that are in fact attached to a compute instance, and then I have 2 that are not. Okay? So at first glance, it's a little hard to tell why a disk might not be attached to a virtual machine, right? Does it have data on it? Like, why is it completely stranded? When we look at how disks come back from the Compute Engine API, this information becomes a little bit clearer, right? So first, here's an example of a disk that is basically the boot disk for the virtual machine, right? Its name is the same as the virtual machine. It has a users field that's populated that tells us which virtual machine is using that disk. It has a last attached timestamp, so this is the last time that it was attached to a VM, all pretty straightforward. Here's another example of a disk that is currently attached as well. So again, it has a users field and it has a last attached timestamp. We also have this example of a disk that is actually not attached at all. It's called it, and I've named it unattached disk just so it's easier for me to find. You can see that it does not have a users field, so this disk is currently not being used by anything. And it also does not have a last attached timestamp field, which means that it was never attached to a virtual machine. This disk was simply created from scratch and never used for anything. We can contrast that with a different disk that I called, let's see, where is a detached disk in this example, where you can see it also does not have any users, but it does in fact have a last attached timestamp, so I know when it was last attached to a VM, and it also has a last detached timestamp, so I know when it was disconnected from a VM. Okay? So this is all information that I'm going to use to figure out what disks do I have in my project that aren't attached to anything, and then basically classify them into, one, disks that were never used, which maybe means I can safely delete them, or disks that were at some point used by virtual machines, might have some data on them that I need to preserve, in which case I need to first take a snapshot of that disk if I want to delete it, or maybe deletion is really not even what I want to do. So what is this going to look like in code? Yeah, let's go back to our code here. So I also wrote this function using the Node.js runtime, and the process here is going to be rather similar. So again, we're going to use the getDisks method to get all disks in my project across all regions. I'm going to iterate through them and get the metadata for each disk. And now I have to basically handle two different cases. The first case is when the last attached timestamp is undefined. So this is basically the simpler case. This is the case that means the disk was never used by anything. And what I'm going to do here is basically calculate its age. And then if that age exceeds a particular threshold, then I simply delete it. Okay. Another option would be, actually, I'm sorry, I simply delete it up here. I'm not even calculating the age of disks that were never attached. I just assume if it was never used for anything, it's probably completely wasted. The other case is if the disk does, in fact, have a last attached timestamp, where then I'm going to calculate its age, and then if the disk's age exceeds a particular threshold that I'm comfortable with, and the disk does not have any users currently, then I can optionally take a snapshot and then delete the disk. So let's go ahead and implement this in a similar way. So we're going to go back to Cloud Functions. Here's my delete unattached persistent disk function. The source is a little bit larger, so I can't quite see it here. Here's my HTTP trigger. And now in Cloud Scheduler, here is my cleanup unattached disks task. Again, it just simply points to that Cloud function. And I'm going to head and run it. You can see the function call doesn't take very long to execute. And let's just see if that run actually worked, if I need to refresh the page to make it happen. All right, success. And now, if I did everything correctly, when I refresh the list of disks, there we are. Both the disk that was created from scratch and never attached to the virtual machine, as well as the disk that at some point was attached to a virtual machine and now is not, have been deleted. Okay. So let's go back to the slides and kind of review what we've covered here. For this particular session, right, we used the very sort of similar automation approach. We're using a Cloud Function to call the Compute Engine API, get a list of all the disks in our project, and then validate two things. One, was the disk ever attached to a virtual machine? If not, we can just say it's waste and let's go ahead and delete it. Two, the disk at some point was attached, in which case we should probably take a snapshot of it because it could have data on it that we care about, and then optionally delete it. And finally, schedule the whole thing through the use of Cloud Scheduler. Let's look at our third example of waste, which are over-provisioned disks. Okay? And I think one of the examples that someone called out was the overuse of solid-state disks, which I think is basically a subcategory of this. But this particular example, and sort of the chart that I've put here kind of illustrates the case, is we often provision disks that have a much larger storage capacity than we actually need because we want additional performance, right? In GCP, disk throughput scales with disk capacity. Okay? So simply looking at storage capacity use for a persistent disk is not necessarily all we need to know to figure out that the capacity is being wasted. We also need to look at IOPS, or just how much throughput that disk is incurring. We also need to look at throttling to understand if that capacity is in fact what's making sure that the disk can in fact deliver the throughput that it needs. Because if we're seeing throttling, that means that we may need to even increase the size of that disk. Right? However, if we're seeing an example like this, where free space for this disk as expressed by the disk utilization metric is at 100%, meaning we're not using any capacity on it. IOPS are basically 0, and throttling is basically 0. This is a very clear-cut example of a disk that's completely over-provisioned, and we need to reduce its size. Okay? And the amount of savings that we could realize there are, again, about 17 cents per gig per month for solid-state disks and 4 cents per gig for hard disks. Now, for this example, there's a couple of complications, right? The first thing is we can't simply poll the Compute Engine API to tell us that, hey, this disk is underutilized. We're actually going to need to rely on Stackdriver monitoring here. Okay? And what we're going to do is create a Stackdriver alerting policy that will monitor our disk usage on our VMs. And when it sees the combination of conditions that we've described here, which is lots of free space, very little IOPS, no throttling, it'll trigger an alert that'll use a webhook notification to trigger our Cloud Function. The second complication here is that the Compute Engine API, at least as of today, does not provide an easy way to downsize disks. There is a resize command, but the resize only allows you to go up. You can make a disk bigger. You can't make a disk smaller. So we actually have to follow a fairly complex set of steps to decrease the size of a persistent disk. We're going to take a snapshot of that disk. We're going to create a new disk of a smaller size from that snapshot. We're then going to stop our VM, detach the currently used disk, attach the new disk, and restart the VM. All right, so let's take a look at how this actually works in practice. Let's go to the demo. So first, I'm going to start in, make sure all my tabs are awake. We're going to start in Stackdriver, looking at a dashboard of persistent disk usage. So here's an example. It's, again, the similar example we have. Utilization is very low. Throughput and throttling are 0. Disk capacity is 100% free. I should note that these metrics are actually provided by the monitoring agent. So you do need to install the Stackdriver monitoring agent on the VM to get these specific metrics. Okay. The second thing we need is the alerting policy that will trigger when these conditions are observed. So I have an example of that here. I've created an over-provisioned persistent disk policy that'll fire when all of these conditions are met. Okay. And in this case, I've made it very conservative. I actually want to observe that this is the case for basically an entire day before I make the conclusion that this disk is in fact being wasted. Right. So now, what happens when this policy fires? So I'm going to trigger a webhook notification. Let me see if I can make this a little bit smaller. And I'm going to point it at a Cloud Function. And here's what that webhook payload is going to look like. Okay? So now, instead of writing a function that simply executes when it's called, I actually need to take in the input, because as part of this alerting policy, I'm going to get the resource ID that I need to use to execute my downsizing process. All right. Let's take a look at the code. So this time I chose to use Python because I was struggling with all the asynchronous calls that this requires in Node. But the process itself is somewhat straightforward. There's just lots of steps to it. So the first thing I'm going to do is get an aggregated list of virtual machines in my project. Okay. From there, I basically look for the virtual machine that matches the instance ID that I get from the Stackdriver alerting policy. Okay. From there, I get the disk of the VM, and I do a disk get, which is basically the equivalent of getting the disk metadata. Once I have the disk, I create a snapshot of it. Right? That's the first thing we have to do while the machine is still running. Once the disk is, once we have the snapshot, I'm then going to figure out what is the size, the new size of the disk going to be. In my demo example here, I'm basically literally just reducing it by 1 gigabyte just to illustrate the point. Okay. In production, what you may end up choosing to do is to actually calculate the new size based on things like what is the IOPS you're seeing, what is the current storage capacity, and things like that. But that's what we're going to do. We need to figure out when we create a new disk from that snapshot, how big of a disk is it going to be? Because obviously what we're trying to do here is downsize, so it should be smaller than the original. Once that disk is created, we then stop the virtual machine. We detach the current disk that is being used by that virtual machine. We attach the new disk, and then we start the virtual machine. All right. And now I'm going to have a, again, for the purposes of executing this, I'm going to have my cloud function. The two things I'm going to note here is, first, because a lot of the calls that I've had to make in order to have this process work are actually basically asynchronous. They take some time to complete. I've had to increase the execution timeout for this particular function all the way to 360 seconds. So whereas others that we looked through, executed in a matter of a second or two, this one actually takes quite a while. And then the second thing where we're going to point out is, again, the trigger here is this is the URL that we then include when we set up the webhook notification for our alerting policy. Okay. And in my example, I'm also going to use Postman, so I basically took that information from my alerting policy, and I manually put in the resource ID for my VM, because obviously this is the best way for me to sort of fake the alert that actually comes in. All right. So I can go ahead and hit send, and while that's running, I think we should move on again, just because that takes quite a bit of time. So let's go back to the slides, please, and kind of summarize what we've covered here. Actually, before we do that, I just want to kind of quickly summarize how we approach this particular problem. So there were two issues that we had to address with this particular scenario. The first one was that detection was not as simple as simply looking at a couple of metadata fields. We actually had to have something that evaluates capacity and throughput and throttling on these disks over time. We're using Stackdriver monitoring to do that, and then creating an alerting policy that triggers when a particular set of conditions has been observed. Then making a call to Cloud Functions, passing the ID of the virtual machine where we observed the violation. Okay. And then the second complication was actually having to basically orchestrate that persistent disk downsizing process through all the various steps that it takes. All right, so let's recap. Actually, before we recap, some things you should consider when you take this to your own environment and start to do this. The examples that I showed you were executing functions within a project and operating on resources just within that project. When you go to do this at scale, what you probably want to do is use either the billing API to get a list of projects that are tied to the billing account, or the resources hierarchy to get the list of projects in an organization. You might want to consider is that deletion may be too drastic of a step, right? Perhaps it's something that's appropriate in non-production environments, but you probably don't want to be deleting resources like this in production. You may want to do things like trigger approval workflows, trigger notifications, perhaps populate a dashboard that shows a resource waste over time, right? Sort of just be cautious about how you do this in production environments. And finally, specifically for disks, again, we talked about snapshots quite a bit, but that is one option. You can, instead of just deleting the disks, take a snapshot to make sure the data is preserved, and then trigger an approval workflow or notification where someone can get notified that their resources may be deleted in the future if they don't clean them out themselves. All right. So to recap what we've covered today, Philip took us through examples of waste in cloud spend and some specific buckets in which that waste could fall into. And then we looked at end-to-end examples of how you can go about first identifying this waste, secondly, cleaning it up, kind of deleting those wasteful resources. And finally, we looked at a session later today. CST 203 will cover aligning cloud costs with service delivery, so we highly recommend that one. And just like Philip said, you can also visit cloud.google.com/cost management for additional resources. After the event is complete, all of the cost management session recordings, including this one, will be posted there. All right. As a reminder, if you have questions, either you can submit them through the Dory Q&A functionality in your Cloud Next app on your mobile phone. We would also love to take some live questions from the microphones. So, Philip, you want to come back up and maybe take some questions with me? Let's take questions from the microphone, please.
First question from the Dory. Are there default cloud functions provided, or do you have to write custom ones? And then as a part two, can you provide the demo check cleanup scripts and make it publicly available?
Yeah, great question, absolutely the right question to ask. So these are not out-of-the-box functions. This code was written essentially from scratch, and we are planning on publishing it as a solution, so stay tuned for that.
The recommendations in the compute engine for right sizing, do those take into account contractual terms that we might have with Google for special pricing?
They do not as of today. And when you say that, do you mean the actual recommendation itself?
Yes.
Or
the
the
pricing,
the cost savings amounts that it suggests?
The cost, well, both.
Got it. The answer is no to both as of now. So the savings amount that you see in that screen is the at-list pricing savings amount, which is consistent with all of the pricing that you see in the compute engine console, which is list price.
Okay.
But if you're more interested in that, come find me afterwards. I'm happy to hear a little bit more about your use case, and we can figure out what will work. Okay. Cool.
Yeah, you had a bullet about part-time idling.
Yes, sir.
And I'm in the middle of actually working on writing some scripts to do follow the sun, shutting down my VMs at night.
Yep.
But the main question I have about it is, do you guys have a rough idea of when, let's say we run at a point to 20 days a week of runtime we need, when does it become, what's the break point against your sustained usage discount?
Got it.
Do you guys have a number, in rough number you guys typically use for something like that?
It is always in your interest to shut down the resource if it's not being utilized. There's no scenario under which running it for longer will save you more money. It's like marginal savings, kind of like tax rates, if that makes sense.
Gotcha.
Yeah, so if you have a wasted resource, in all cases, at least I've never been able to find a case where it is cheaper to keep it running because we don't do like back to your first dollar discounts. It's always on your incremental spend.
Got it. All right, thank you very much.
Yeah.
Hi, so my question is more from a governance standpoint. Is the recommendation that these centralized functions be consolidated into one project, which maybe finance, accounting also has access to, and then the specific reports go out to different project users assigned to them?
Yep. In most of the customers that I've seen that have gone and tried something like this, the pattern that seems to work quite well is to have at least one central administrative project that would implement, say, like your financial governance controls, your cost optimization stuff, and you'll have like a service account running there that'll get kind of like super user privileges to all the other accounts.
Yeah.
That way, not everyone, you don't have to replicate this in every project, and not everyone can go in and change everything.
Yeah, because what we did today is we kind of just centralized kind of an ops project.
Exactly.
Where we dump all the billing information
Yep.
and then make Data Studio dashboards available to different stakeholders.
Yeah.
So that was just a perspective question.
Yeah,
Thank
that
you.
seems like a good pattern.
To add to the question he asked, do you guys have service accounts for organization?
Say that one more time.
Do you have service accounts for the organization, or it's just the user?
Service accounts are still project level resources. So you would need to, if you wanted to do this across projects, you would need to create a service account in the, the ops project and then give it access to delete, clean up resources in these other projects.
Right. But you can give it IAM privileges on the org level, right?
I believe that's correct, yeah.
Yep. I'm using a user level now, but just you mentioned service account, I was like surprised. Is it possible?
Yeah, okay. I'm also, in fairness, I am not an expert on IAM, so you should go talk to someone who is, if you have more detailed questions on it.
A general question to a PM of a cost management.
Yeah.
Are you planning to allow tagging or labeling for all types of resources?
Are we planning to allow labeling for all types of resources? That was a question?
Yep.
I don't want to give the wrong answer to this one. I know that we are planning to increase coverage and consistency of labels across resources in the fullness of time. If you have any specific resources that you are interested to know when can we apply user labels to them?
BigQuery.
BigQuery slots. Good question. I'm not the right person to answer that one. I would direct you to, I can actually direct you to the person who will have the most precise answer. So come find me afterwards. I'm happy to hook you up with them. Okay. Austin?
Second question from the Dory. Does the VM sizing recommendation API take into account all usage metrics, including I/O and network? Reducing the number of vCPU could unexpectedly have a negative impact for I/O or network-intensive apps.
I believe it does take into account network and I/O. I think it's RAM utilization, core utilization, and network and I/O. But I'm pretty sure it's in the public docs, so we should go double check that as a final say there.
And just to clarify, right, there are two parts to it. There are the recommendations themselves, which have been around for quite a while now.
Yes.
The new thing is the fact that you can now act on those recommendations using an API rather than just having to go to the console.
Hi, so you mentioned having the output of some of these operations go to a dashboard, and
Yep.
inevitably, if we implement something like this, I'm going to be asked, like, how much money did we actually save by doing this? Do you have examples or guidance on what a proper dashboard for this might look like? What should it contain, just to be able to answer those questions that I would, be asked by, finance or whoever about what do we save and what do we actually, do here?
So I don't, but this is a problem that I actively think about. So if you're interested in it, come find me afterwards. I'd love to chat a little bit about what you think would fit well in there.
Sure, thank you.
Yeah.
There may be a conflict of interest on this question, but there's lots of vendors downstairs that sell services as cost savings, right?
Yeah.
They analyze your
Yeah.
GCP spend. So maybe in your experience, is there one vendor that you like over the other? What do you think of the cost saving?
I'm going to pass on that one. Here's what I'll say. This is going to be a very PC answer. We have a lot of really good vendors that fill a lot of those gaps where you might want some functionality that we don't provide natively today. I would encourage you to go have a conversation with them and see which one fits your needs best, because some of them fill like slightly different niches, so it just depends on like what's your most pressing need.
Yeah, Cloud Health, that's it. And then second question, if through GCP support, could you put a case in for an analysis like you're doing with the scripts on cost savings for persistent disk? Is that something that support would do, or is this more of a you need to do
So
yourself?
you're asking, would support do something like we just showed on stage and kind of put that analysis together on your behalf?
Yes.
The answer is I don't think support would do something like that today. We do have other capabilities within Google Cloud, like our professional services organization, that's more equipped to do something like this.
Okay, thank you.
Yep. Austin?
Another Dory question. Does AutoML, or rather, can AutoML help detect over-provisioned disks?
Sure. If you give it enough example cases, I'm sure it could. I actually haven't tried it, but I see no reason why that wouldn't work. In fairness, though, I'll also admit that something like this is a pretty good candidate for like a simple heuristic-based approach. So maybe it may not be necessary, but it probably would work, yeah. Good. I'm glad we got applause for that.
Someone agrees that ML is not always the answer.
Right, ML is not always the answer. But it can be useful. Any other questions, live or from the Dory? We have maybe time for one more. And then also, if anybody does have questions that they don't want to ask to the group, feel free to come find me, Yuri, or one of the other Googlers in the room to ask questions after. But I'll try one more.
One more from the Dory.
Actually, no, we got a live one behind you.
Okay.
Yep. We'll take the rest of the Dory questions offline and try to get to them over the next week.
There's the VPA available for GKE, the vertical pod autoscaling.
Yes.
Will there be something like that available for GC, like auto vertical scaling of the GC instance?
Got it. I am not the best person to answer that one either, but I do know who the right person is. So again, let me find you afterwards, and I'll give you their email, and you can ask them directly.
Okay, thanks.
Perfect.
I think that's time.
All right, that's it. Thanks, everyone.
Thank you.
touch and get lost in the desert, so we can dig it back up. Look at us go. All we need, all the basics. Throw a dart at a map on the wall and go wherever it sticks. Lighting on fire. All we need are some matches. You and I burn the trail as we go. They will never catch us. Look at us go. All we need are the basics. Throw a dart at a map on the wall and go wherever it sticks. Come on.
Another dimension, another dimension, another dimension, another dimension, another dimension, another dimension, another dimension,
Another galaxy, far away, where every day they're dancing to the beat. That's always popping, skinny, dipping in the stars. Wherever you are, yeah, it don't matter, girl. Have another cosmic cosmopolitan. It's that kind of night, yeah, it's that kind of night. We're ready to take flight, rolling like a rocket. Yeah, it's that kind of night. It's that kind of night. We're ready to take flight to another dimension, another dimension, another.
All right. Wow. Hello, everybody. Hope you're all having a great time at Cloud Next 2019. My name is David Conway, and I lead product management for Currents. Today, I'm going to talk to you about Currents and have some teammates do a demo. And then we're going to have some of our early customers up here to talk about their experience. We will take questions at the end. And so if you want to enter them in the Dory, you can go to the page in the Cloud Next app and click Dory Q&A and enter your questions there. All right, so where do we begin? Well, today, employee engagement is at an all-time low. By some estimates, 87% of employees worldwide are unengaged. The business press tends to define it, engaged employees, as those who feel passionate about their jobs, are committed to the organization, and put in discretionary work in doing their jobs. And in today's knowledge-driven economy, keeping employees engaged is important now more than ever for getting the most done and getting the most out of your workforce. But deepening this employee engagement is actually really hard to do. But we think it's a really important problem worth solving. You know, you see that companies with engaged employees versus none have a 2.5 times earning per share difference. And there's very high correlation between engaged employees and retention of employees. So I think most people know the costs of employee attrition. So it's really a problem worth solving. And a key part to that solution is your communications tools. Many organizations today have employees distributed across the globe, across time zones, but they all need to work together on a shared mission. And increasingly connected deskless and frontline workers, they've got mobile phones in their pockets, they're part of this experience, but they don't have the time to manage an email inbox, or they can't be getting interrupted with a beeping phone while they're in front of customers, for example. But it's still absolutely critical to keep them engaged in the company mission. And then when you talk to leaders, a couple of really clear things come through. First of all, they want to lead, they want to get their word out, but they also want feedback. They want to understand the impact they're having. They want to understand how people are responding, what the sentiments are, but they struggle with the right tools to do this. They all send out the big blanket emails, but are frustrated that nobody replies to them. That's sort of one thing we hear from leaders. And then the other, just generally, is They want people to work as productively as possible. They want best practices shared. They want information to get out of the traditional silos that form in organizations behind access control lists or in people's inboxes. And so they're looking for ways to solve that. So enter Currents. I think most of you probably heard about it yesterday. We're pleased to announce Currents as the newest member of the G Suite family. It's going to be included with the basic SKU and hire of G Suite. You can request to be in the beta by email now. I'll show the address at the end, and it will be in general availability by the end of the year. Currents is the new name for the reimagined and redesigned enterprise version of Google+, as we've now shut down the consumer version. Currents is focused squarely on solving the problems that I've been talking about, and it's all about enabling organizations to connect knowledge, ideas, and people at scale. I'm going to take the next few minutes to walk you through the key benefits for Currents and with different types of users in today's organizations. And after that, we'll have the team come up and do a demo, and then we'll talk to some customers. All right, so if you're a leader at a 10-person company, you don't really worry about employee engagement. You're probably sitting in the same room. There's a lot of tools that can work for that. And the same when you're at a 100-person organization. But when you get to a certain size and a certain level of distribution, you just need better tools. Currents aims to engage leaders and employees by giving leaders the tools to do a bunch of things. One is to just create great and compelling content. And as you'll see, we're doing that with subject lines for posts, rich text, drive attachments, so that they can put their best foot forward in their communications. It's also important to be able to highlight content to drive alignment in the organization. And there's two ways you're going to see to do that. One we call Leader Spotlight, and another called Custom Streams. Generally, it's just important to foster open discussion across the enterprise, regardless of hierarchy, and to create quality discussions and evergreen content. One of the key things you're going to hear about is how we're doing routing based on tagging. Users are able to use hashtags in the way they do in products today, like Twitter and Instagram, et cetera. And then people can follow those hashtags in their organization for specific topical areas that are relevant to the organization. And then ultimately, we know leaders want tools to be able to gauge that sentiment that I talked about before, and you'll see some of that as well. And ultimately, with all these things, leaders are able to drive a shared understanding on the important topics and initiatives across their organization. We're going to have Narina up here shortly, but I wanted to share this quotation. I'll let you read it yourself. But they've been using Currents since November, deployed to the entire organization in January of this year. And they found value in how Currents facilitates meaningful discussion and allows their employees to exchange ideas. She's not shaking her head, so that's good. But leaders are not the only beneficiary when an organization deploys Currents. Currents also enables rank and file employees not in full-time leadership positions. First of all, it's an organizational commons for ideas and discussions across geography, time zones, and information silos. And it gives people an ideal way to interact informally, including with leaders, about company topics. And if they don't think the right folks are included, they can extend the reach of the discussion, say by adding a hashtag and a comment, which then sort of routes it to anybody following that discussion. And we think this is really powerful. And specifically when they're stepping up in their role and they need to actively campaign for some promotion or initiative or something they're doing internally, it gives them a way to promote their work-related content to people beyond their immediate work team. We've got lots of tools to work with your immediate work team, but if you actually want to reach in one of these larger companies to people, say, in your same role but in a different place, or people with shared interests that you've never met before, it's very powerful. And then finally, it gives them it gives them a way to share fun and insightful and inspirational parts of their work lives, which I think builds a sense of belonging, which is important to a lot of companies' cultures. And it does all of this with a post and comment model with an ordered home stream. It can be sorted chronologically. And they see the things they're interested in that they follow so they can make the most out of the time they spend using Currents. We're not trying to trap people there and show them ads. We want them to get in, get value, learn something, and get on with their job and be better at their job. And so ultimately, when you do this, ideas can be exchanged broadly and efficiently in a way not really possible with existing tools today. Oops, there it is. Another quote from ATB. They've been using it since September of last year and deployed to the entire company in October. They've loved how Currents has allowed them to connect ideas and employees, making it easier to engage in discussion across the company. So we'll have people from these companies up here in a moment. The last thing I really wanted to talk to you about, though, is this critical area of content management. Today's work environments are increasingly complex as companies manage global workforces, and these lines between your personal and your work life really blur. Leaders in human resource departments want collaboration, but also want to keep the conversation respectful and professional. Every company is going to solve this in their own way based on their culture, their environment, et cetera. So in Currents, what we've done is we've built tools for them to implement their workplace policies and steer their organization's behavior and discussion in a way that works for them. We call this new role that of the content administrator. And these content administrators are catalysts to shape the discussion, drive engagement, and ultimately shape the desired norms. And so while they can do things like take down posts if there's something offensive, there's lots of ways to handle that, but you can just take it down in Currents. There are also management tools for some of the features I've talked about around tags. You see it there, tags, leaders, and streams. So these are sort of the people out in the field steering, in the organization, steering the discussion and shaping it. And so ultimately, this lets them build a respectful space to shape their culture. So before we go to the demo, I just wanted to recap that Currents enables organizations to connect knowledge, ideas, and people at scale. And we've talked about how leaders can drive alignment and get the pulse from constructive discussions across the organization, how employees can interact informally but efficiently with people outside their teams and leaders and just people they may have never met before to get better at their jobs, and then the importance of this content manager role to catalyze and shape the tone at the company. And so with that, I'm going to invite my team up, and if we could switch to the direct input for the demo here, that would be great. Oh, you can clap. All right. So this is Pam, Alex, and Rahul, and they're going to walk us through a demo. Good. I'm going to step off.
Good. Hey, everyone. Thanks, David. I'd like to introduce you to Pam. Pam is the CEO of GrowCorp, an international retailer that has stores worldwide. Pam has just returned from a trip to Singapore, where GrowCorp has opened its first store in the country, and she'd like to share an update with the entire organization about her trip. So she clicks on Share an Update, types in a post title, and then puts in her message. As Pam types her message, she sees suggested tags, #kudos and #customerlove, which she decides to put as a part of her post. But then she also puts in another hashtag. As she types the keyword hashtag, she sees suggested tags. And suggested tags in Currents is a great way to reduce tag fragmentation in the system. So she goes ahead and she puts in the hashtag wins. Then she goes over to Drive and clicks on the icon. And then she attaches a presentation for the entire organization to see GrowCorp's plans to expand in Asia. And then she goes over to the top right-hand side and clicks the Spotlight button. The Spotlight button allows leaders such as Pam to further highlight their content in Currents. She goes ahead and makes her post.
Let's switch over to Shane. And let me introduce you to Shane, who is the store manager of the new Singapore store that Pam just posted about. So sometime after she made that post, after a long day at the store floor, Shane goes back to his office, and he comes to Currents. And this is where he tries to catch up with the latest, with what's been going around at Grow Corp. So from his home feed, as David mentioned earlier, this is where he can find the latest relevant posts from the people and tags that he's been following, as well as posts from the communities that he's part of. In addition, this is where he gets to find out what are the latest popular posts that people are talking about throughout Grow Corp, as well as recommended posts from leaders, such as the one that Pam just posted right here. Now, Shane decides to take the chance to respond to Pam by acknowledging the great work that Tanner has done together with his marketing organization in the recent launch. Now, by providing signals such as the marketing hashtag, this ensures that Currents will give the visibility of this post to the entire marketing organization. Now, this is a simple yet lightweight and remarkably powerful action that enables Shane to give a loud shout out across the entire organization in a non-disruptive way. In addition to being able to engage in a two-way conversation with leaders like Pam, and really fostering that type of employee engagement that David was referring to earlier.
So switching back to Pam, a few hours later, Pam goes back to her feed and she notices Shane's comment on her post. She scrolls further down her feed and she sees a post that she had made a week ago is getting quite some traction in the organization. Curious as to where that traction is coming from, she clicks on the overflow menu and then selects View Post Analytics. Over here, she's able to see the number of views, comments, likes, and reshares on this post. But what Currents also gives is further a way to get deeper insights for a post author to see where the engagement is coming from. So over here, you see the names of senior leadership from Grow Corp, and next to their names is the percentage of the amount of engagement that has come on that particular post from that leader's organization. So this way, the author is able to get deeper insight into where engagement is coming from, and then they can decide how to change their communication strategy going forward. Pam scrolls further down in her feed, and she sees responses to a poll that she had put out to the company a week ago. And she sees that 401k matching is top of mind for most employees, and polls are a quick way to get feedback on things that leaders would want so that they can take action for things that are important in the organization.
Now, switching back to Shane for another moment, I would like to take this opportunity to show you a couple more ways that Currents connects people and ideas at scale, while also shrinking the distance between employees, as one of our customers aptly described it. So as Shane goes back to his home feed, on the upper left, he sees the trending tags. This is like the digital version of the water cooler, where you're walking down the hallway and you see, what are people talking about? And in this particular case, something that catches Shane's attention is the hashtag vitamins trending tag. This is a topic that his own customers in his Singapore store have been talking about, so he's curious about it. So he goes ahead and clicks on it to drill down to see what are these latest conversations that people are talking about. Before going further, he actually takes this opportunity to follow this particular tag. And in doing so, now, going forward, whenever he comes back to his home feed, he's gonna get the latest on hashtag vitamins. As he scrolls down, one of the things that he notices is actually a recent post by Cassie Teller. Cassie is a purchasing manager from across the world in London. And she's talking about a vitamin line that his own customers have been talking about. So he was really excited about it. And he takes this opportunity to actually respond to Cassie, saying, hey, this is really interesting for my store. Now, this simple action connects these two individuals together from across the world. Now, going forward, whenever Cassie is thinking, wait, what's going on in Asia, she now knows that, hey, Shane's the person who's interested in this particular topic, and vice versa. Shane, going forward, knows that Cass is the go-to person for this particular product line. Now, before going forward, Shane also stars this particular post, so he can refer to it later by simply going to the left menu and the start menu. And this is very similar to how it works in our other G Suite products like Gmail and Drive. While I have you here, your attention in the left menu, I also wanted to call your attention to the lower right, to the custom streams. Out of the box, Current supports some of these custom streams like Spotlight. This is where Shane can come and see what are the latest posts from leaders. But in addition to that, there are additional custom streams that the content administrator at GrowCorp can set up to highlight posts on topics that they want to be front and center in people's mind. So in this example, the administrator set up a display ideas custom stream. So Shane can quickly drill down to see, hey, what's the latest great ideas that people are exchanging about displaying products throughout GrowCorp? So this is a simple and also powerful way that companies like GrowCorp can actually scale their culture.
So I'm going to introduce you to Peter. Peter is an internal communications manager at GrowCorp. So Peter's role is to help senior leadership at GrowCorp send their message out to the rest of the organization and also ensure that the organization has a shared understanding of where GrowCorp is going. As David mentioned earlier, we are introducing a new role called the content admin with Currents. And the G Suite admin for GrowCorp has designated Peter as the content admin for Currents. So when Peter logs into Currents, he sees the new management tool link in the left-hand side panel. He goes ahead and clicks on it. And then over here, Peter is able to manage tags, leaders, and streams in Currents. With tags, Peter can upload new tags to the system. And what this does is allows Peter to shape the conversation and also reduce tag fragmentation. If there are certain tags that Peter wants to exclude from recommended streams, he can do so, or he can enable them again. Moving on to the leaders panel. Over here, Peter can designate certain users as leaders in the organization. And what this does is gives these leaders access to features such as the Spotlight feature, which they can use to further highlight their content within the organization. Then moving to streams. Streams, as Alex mentioned, are a great way to yet further highlight content within the organization. So over here, Peter notices the announcement stream is not yet activated. He's been working on it. It's ready to go live. So he selects the announcement stream, and then he clicks on the activate button. As you can see here, Peter has chosen to make this stream available to all of GrowCorp. But if he so chose, he could make it available to a subset of the organization using Google Groups, and only those users would see that stream. So he goes and clicks activate, and the stream shows up in the left-hand side panel, ready for use. So that's what we had for the demo. Back to you, David.
Can people hear me? Here you go. Thanks so much, team. That was great. All right, so let's talk to some real customers. I guess I do. Can we go back to the slides, please? Oh, we are on them. All right, so I'd like to introduce Narina and Michelle from Nielsen and ATV Financial, respectively. As I mentioned earlier, they've both been using the product for many months. I was wondering if we could just go one at a time and have you guys say a little bit about yourself, your company, and your journey so far.
Sure. So hi, everyone. I'm Narina. At Nielsen, we have over 40,000 employees in 100+ countries. And Currents has really allowed us to break down those not just geographical barriers, but also organizational barriers. So regardless of what your title is or what your zip code is, you have the opportunity to engage with leaders in the company share your ideas and form communities around something that you're passionate about. And this has really created a culture that is open and engaging. And it's really important for us, especially right now as a company. We're going through a lot of change. We just got a new CEO, and he has been very dedicated to the platform, which has been so important for us. So it helps associates feel more connected with what's going on in the company, but also adds a personal aspect to it. Our CEO has been traveling around the globe. He's been posting to Currents pictures of where he's visited, what he's learned, and it really, makes for a more personal experience for our associates. We've used Currents as a primary form of communication at Nielsen. Kind of trying in an effort to reduce the amount of email that everybody is getting. And the new features around streams have been a game changer for us, really. One of the challenges we had in the past is how do we ensure we're reaching the right people if we're going to use this as a primary tool for communication. And so we find ourselves posting in different communities, trying to ensure that we got to the right audience, and Streams has just completely eliminated the need for that. And with the post analytics, we actually now have some feedback as to the engagement that we're getting. So we've been super pleased with the new features, and I'm sure we'll get into some more details.
Great, thanks. Yeah, and maybe before we go to Michelle, I'll just say, we didn't really talk about communities today. It still exists in the product. It's something our customers have loved and used in Enterprise Google Plus over many years. It's not going anywhere. It's not absolutely not going anywhere. But they're still very useful for when you want more contained conversations. But so I'll just set that context. But maybe just rewinding a little bit, Michelle, can you tell us about yourself and your company, and maybe an interesting anecdote from your side?
For sure. Thank you, Dave. Hi, everybody. My name is Michelle McCarthy. I am the Technical Advancement Leader at ATB Financial. And ATB Financial is a financial institution in Canada, Alberta specifically, and we serve we serve all customers throughout the province of Alberta. We have about 5,500 employees, and something specific about the team that I work with is that we're responsible for the G Suite proficiency of the organization as well as adoption. And we're also responsible in partnership with other teams within IT of removing or decommissioning our Microsoft products. So we are the team that is really in front of team members, understanding how they're using the products and how they're adopting the products, and in turn, how we're removing the products that we don't longer use in the organization. So with Currents specifically, we adopted G Suite in July of 2017. And what was really important to us was that we were using these tools. And so quickly we adopted Currents, G Plus communities in the past. And we're at the point where we have 90% of our employees who actually use Currents about once a month, and then about 65% of employees who are going in at least once a week. So it is a really popular avenue for us to share information throughout the organization, and it's quickly becoming one of our primary methods alongside others to ensure that we're distributing information to all of our team members. So it's something that we can't even imagine not having today. And I would say that specifically with the changes that have been made is that absolutely in the past it was very siloed information that were provided within the communities, whereas a focus for us is to ensure that we're getting the right information to the right people at the right time. And so the tags specifically ensure that it allows us to provide the information that team members may not choose to go to and get themselves. So in the past, we allowed team members to select the communities that they wanted to be involved in, whereas now we can ensure that we're doing it from both perspectives. They have the option to select the information that's relevant to them, and they also now have the option through tagging, getting the information out to everybody that's important to us as an enterprise, as well as what may be important to the division or the department. So absolutely, hands down, it allows a much broader distribution of information across the organization.
Great, thanks. I'm wondering if, whoever wants to take it first, you could talk a little bit about your deployment experience, how you rolled it out, and specifically how it changed the balance. I know you have a story, Michelle, about sort of de-emphasizing communities and moving more to tags. You're still holding the mic. Do you want to maybe talk about your deployment experience, and then we can go to Narina on that?
Sure.
Yeah.
So something that stands out in my mind in particular is now with the new look and feel is that it's very modernized. So our team members are comfortable with the look and feel, absolutely going from seeing about 4 different articles to going to one. At first the question was, why can't I customize it? Why is it only just one? And that conversation stopped. Like, we didn't hear that for very long over the course of 2 weeks. People just simply got used to it. So something that was easy to adopt is the tagging, because that is something that you do if you are a social media user all the time. So people just naturally started doing it. You just had to say tagging is now available. And that was something that was just naturally adopted by team members. So now I would say everyone is doing it. For even people who weren't used to doing it, that's just something that they see being done, and they're like, well, I want my information that I'm sharing and posting to get out to a broader audience, so I'm going to start tagging as well. And you wanted implementation?
I know you had this story that I love about how you had almost too many communities before and basically decided to retire some of them and replace them tags. I mean, there's still a role, right, for a community sometimes where people want more privacy, but
yeah. So we have a lot of communities because what we wanted to achieve was adoption out of the gate, and we certainly did do that because of the fact that it's been less than 2 years that we have had G Suite in our organization. So we had a lot of communities. So and we still do. So it was very open to all employees to be able to leverage that tool, to use it as a social tool alongside using it as an interactive tool to get to know fellow employees from a work perspective, as well as to get the information that they needed to know. So I lost my train of thought. That's terrible.
Well, you were just talking about, tagging in communities.
No, I lost my train of thought. I was too busy looking at the beautiful Pam in the first row.
No, it's great. We'll come back to you if you like.
Sure.
Yeah. Okay. How about Narina? Do you want to talk a little bit about your deployment experience?
Sure. So when we first heard about Currents, wasn't called Currents at the time, but basically what it was is new enterprise features coming to G+. We were super excited. We partnered with some of our key stakeholders in our adoption of the platform, our communications teams. They've always been really passionate about G+. They're the ones that really help us get the buy-in from the leadership and make sure that they understand how to post and when to post and things like that. So the first thing we did was engage them, and we had a few sessions with Google where they shared, what are the features that are coming, and we thought, okay, how do we want to position this to the organization? Initially, we rolled out to a small group of users, what we call our Google Gurus. These are users who enjoy testing new features, pre-production features from Google. So we put it out there, and honestly, not a lot of training was required, which I think just speaks to the usability of the product. But we explain, here are streams, and our communications teams helped us identify, what are the streams that we want to start off with. We use Currents a lot for enterprise-wide campaigns and initiatives. And so at the time, I think we were having an initiative going on. It was called My Weekend. And it was basically, hey, tell us what you're doing on the weekend. Let's get to know each other a little bit better. And so we use that hashtag. And I have to say that the feedback that you get from the system, the validation around the hashtags, I'm terrible at creating hashtags. So for me, it's really nice that something gets suggested to me, or at least I have some level of validation that says, hey, yeah, 1,000 other people have used the same hashtag. You're probably on the right track. So we kicked it off with a few, predefined streams, some hashtags to get the campaign going, and really right off the bat, we're like, this is really great. We need to expand this out to the rest of the organization. And so that's what we did. And our communications team have really done a great job of working together to understand, okay, these are the streams we want to put in place. And because these streams now cover, what these 5 other communities used to do, we can retire some of these other communities that were more siloed, like you said. So that was kind of how we rolled it out and going strong.
Great. That was like the perfect segue to my next question about campaigns. Are there specific campaigns? Can you talk about how you've set up streams and the type of campaigns you've done at ATB Financial?
So we, in our streams, have set it up so that we're sharing the most important information and topics. And specifically, what's really important to ATB is wellness. So that is one of the streams specifically that we have really zoned in on to ensure that we're showcasing and sharing any topic around wellness. So anything that is broad to the enterprise is how we have set up our streams. So we don't have very many because it's not about inundating the team with information. It's about being very specific as to what focus you want to draw people's attention to. So when I was listening to Dave speak about how it changes the culture of your organization, it really does, because of the fact that you really want to hone in on what is most important that you want to ensure that all team members are going to be talking about, because it's not just one-way communication. So I'd say it's absolutely, hands down, it has everything to do with ensuring you're sharing your most important information that you want people talking about across the entire enterprise.
Great, thank you. I thought we could maybe pivot a little bit to some of the softer stuff around culture and innovation and things like that, and if you've noticed a change from sort of before you were using this product to now in terms of how people interact.
Sure. For us, I really believe that Currents has created this safe place where people can share their ideas. And for us, it's really about making connections across the organization because we are so spread out all over the globe. Somebody that has an idea or wants to, share something can now go to Currents, put it out there, add a couple hashtags that, maybe will connect them with the right audience. And that's something, if you think about trying to do that in more traditional forms of communication through email or asking this person if they know that person, it's just a much more efficient way to connect people across the organization. And, occasionally there's a healthy level of debate that happens around certain topics. That's also great for innovation. But certainly we have seen teams connecting, and a lot of times it's things that aren't related to necessarily their day-to-day job, right? It's something that they're passionate about or something they've read out in the industry that they have opinions on. And what's great about it is because we do have leaders in the organization that engage with these types of posts. I feel like associates really feel that they're being heard. So that's one example.
Okay, great.
I would have to echo everything that Narina was saying. It absolutely does allow for people to hear from their leaders a lot more than what they had in the past and have interactions with them because your leaders may not all be in the same place. And you interact with leaders that are not necessarily within your department or your division. So I can't say it any better than what Narina has.
Great. Yeah, I think I remember an anecdote from ATB about, tell me if I'm mischaracterizing this, but basically it's a place to be yourself, sort of separate from the hierarchy, and I think the guy said, just don't be a dork. I forget who it was, but so we have tools to take down posts if someone is being a dork. But and in fact, one thing we learned on the product side from working with ATB is there were times when leaders wanted to be leaders and have their stuff highlighted, and there were times when they just wanted to be like a regular person. And that's actually, we took that feedback, and that's why we've added this spotlight feature that makes it optional for the person, because sometimes leaders want to be kind of regular people too and not have their weekend barbecue post be at the top of everybody's stream.
Yeah, it absolutely humanizes everyone.
Yeah.
So I feel as though I'm really fortunate because it has certainly, it fits in well with our culture. So it is a way of ensuring that everyone really feels connected to each other, because that's one of the things that we really focus on. And of course, this type of culture doesn't occur overnight. So team members are becoming more and more comfortable just simply being themselves in their posts and not being afraid to post. And it is because of the fact that leaders are leading by example within it.
Got it.
I would just add that, you know, for us, we did do a little bit of training up front for those that sought it out. 'Cause I think it's important to remember sometimes that not everybody grew up using social media, or if they did, it was a lot of times in their personal lives. And so sometimes there's some anxiety around, well, how do I do this in a corporate environment? What's appropriate, what's not appropriate? And for us, it was really simple. It was, you know, putting out a few examples of, hey, here are some things that you can post about, and, you know, helping them to feel more comfortable in doing that. But I think you're right, like, so much of that just happens by leaders leading by example and people seeing that and then kind of learning the landscape. But I do think it's important to remember that not everybody is gonna feel ready to jump right in, and, you know, what are the things that you can do to kind of help ease them into it.
Great. I have one more question, and then we can go to some Q&A from the audience. I've got a bunch of Dory questions here. I wanted to ask specifically about the knowledge that people take away from it in doing their jobs, and if there's examples of sort of, you know, specific actionable things. I mean, there's one customer that comes to mind at a retailer. This isn't either of you guys, but just as an example of where they actually were able to do a product recall on some damaged food item pretty quickly because someone took a picture of it, posted it, and it just got handled like much quicker than it would have in the old way. Are there other examples of places where, you know, this method of connection and communication made a difference in the business in a more day-to-day way?
One that I can think of offhand is we have, today it's a community, I think it actually probably needs to transition to a stream, but we have a place for people that are interested in using actually Google App Maker and App Scripts. And, you know, my team, we're pretty small team that manages the adoption of G Suite, and we can't always like help everybody, you know, create these apps that they want to. So there's a group of people who have kind of raised their hand and said, hey, I'm interested in doing this. Pretend like I keep
but it's
saying
good. Say currents.
Okay, it's gonna take some time, we do have all of our like features that we release through G Suite are communicated through Currents, and we kind of capture feedback from associates that way that we can bring back either to adjust our change management plans or actually bring back to Google as something, you know, that we're hearing from the enterprise. So a couple examples of how Currents has helped us actually get projects done, and also, you know, where we are able to capture feedback that then we can share with the vendors or whoever it might be to improve.
Got it.
I would say that our journey has been exactly the same. We absolutely use it for day-to-day support. So we have the different communities set up for day-to-day support. And one of the most important communities that I would love to brag about a little bit is the G Suite update community, as well as asking for feedback, as well as any questions that you have. So that is one of the forums that we use to be able to provide insights about any changes going on with Google, and then allow team members to ask questions back, whether it's about the update or anything else. We have one of our larger teams actually that uses it as a supplement. So as a supplement to their primary source of sharing communication, or their primary channel, and it's quickly becoming very, very popular. So our retail financial services team, which are all the branches, they use that for any questions that a team member may have. So they just expect that the timing in which they'll get a response back may be longer than what they get it back in chat. So it is used every single day, and that is why you see our adoption rate so high and so many people going into it regularly.
Okay. I'm going to go to Q&A now. If you guys would stay up, that would be great, just in case there's, you know, a way you address it. But please give a hand to our panelists. I really appreciate it. There's a couple of quick things from the Dory I just wanted to address. We actually have a lot of questions, so we'll do our best to answer those in the Dory afterwards. There was a quick question about, will Sites and Currents work together? There's an existing integration actually between Sites and formerly Google+, now Currents, that will continue to work. If you have a specific question, our PM Alex for that is here. But the answer is yes, you can embed you know, a content stream there. Another one about, is it mandatory to create a profile for each user as it was in Google+? That is, yeah, there's Rahul. That is something that by the generally available release will be fixed and addressed. That's the second question. Two questions sort of about access controls on drives. You know, can we post and share docs that are in the team drive, and how does Currents handle sharing settings when adding docs from Drive? You can put any link or any doc in there, and then if the person doesn't have explicit access to it, they can request it in the normal way. There's not a hard sort of sync between the ACLs at this point. And then the last one, and then I'll go to live questions. Will there be an option for including trusted domains in the walled garden? So we are keeping the ability for G Suite customers to interact with each other in domains, in communities through an invite model, and that will be part of the release as well. Not at this point for overall entire domains, but there'll be an invite model where people from other G Suite users from other domains can participate. Why don't we go to our first live question?
Yeah, thanks. I was curious about how, like, the experience of language translation comes into play. So now you have a CEO who might only post in one language. Traditionally, we've done painstaking work to translate formal communications, but this is a different, you know, change, right? So just wondering, first of all, how companies that are global, you know, kind of address this changing culture. But then also technically, just what's the experience? Is Google Translate sort of layered in there, you know, somehow to make it a better experience and that kind of thing?
Yeah, sure, great question. It is integrated in for translating posts when it's not your language. We actually were talking to a customer yesterday about this issue, and they have a few key languages they use globally. They're all around the world, and when they do big posts, they do translate that into those key languages. So there you go. Let's take another live question.
Hi, thank you. Questions for Norina and Michelle. How do you all work with or evaluate and sort of integrate technology partners that basically integrate into the G Suite ecosystem? The reason I'm asking is I run such a company, and I've been a partner on the EDU side, and we're sort of looking to do similar things on the enterprise side. And since you all are early adopters, I'm wondering how you think about sort of technology partners that are part of the Google ecosystem, and how you all look at that for your organizations.
So by technology partners, you mean like Google partners, or?
Yeah, so Google partners that basically integrate with G Suite, right? So there's lots of third-party applications out there that are part of a partner ecosystem. And since you all are sort of all in, I'm wondering how you sort of look at things that add on to the platforms that you're already using for Google.
Sure. You know, I think that we're always looking at, you know, how we can enhance the way that people work. And sometimes that is using third parties or other technologies. I think for us, it's really important that whatever that tool is that the user experience is really cohesive and you don't feel like you're taking the user outside of the platform from where they started. I'm trying to think of anything specific to Currents, you know, that I could think of an integration. I can't think of anything offhand right now, but I also think, you know, as Google continues to deepen the integrations among their own products, that, you know, some of those use cases may come to fruition. I don't know if you have anything to add.
You know, we're out of time. I'm going to take one more question. I know those guys in the back have been waiting patiently, so I was actually going to queue you up, sir, who just stepped out. Go ahead.
Yeah. Hi, I'm Holger from +2 Trainings. We are a specialized training partner in Germany, and we really appreciate that Currents is reborn at this name from Google+, so it's not dead. Thanks. I'm consulting in social media and employee branding as well, and I'm highly interested if it's possible to do somehow competency management with Currents to show what people can do, where to place them in what projects and stuff like this. Will it be a plug-in system, or is this already a functionality like this?
We have some training materials, and we're certainly analyzing usage and whatnot, but if you want to come down and maybe talk to us afterwards, because I know we're out of time now, be happy to talk to you about that further.
Thanks.
Okay, thanks everyone. We're out of time. Really appreciate it. Thanks for coming.
afternoon and welcome. I want to thank everybody who's joined us this afternoon. It's great to see such a full crowd. I also want to welcome everybody on the live stream or those who are going to be watching the recording. I thank everybody for your time and for your attention. Super excited to be here. I'm Charles.
And I'm Eric.
And together we're both part of the Google Cloud Developer Relations team. And we focus on G Suite. And one of the neat things about the work that we do is we get to see all the interesting ways people try to use G Suite to build applications. And our kind of favorite specialty, both because we find it really useful, but also it excites us a lot, is the way people use spreadsheets in their organizations. And so the idea behind this session was, let's talk about how do we take take spreadsheets and make them into applications. Now, real quick, a little bit about this talk. We're really not here to talk about all the deep feature functionality of spreadsheets. A lot of folks know that. We're really here to talk about the journey and the life cycle of an evolving an idea from innovation and creation right through its life cycle and beyond as well, too. So we'll talk about the different progress and the journey that a spreadsheet can take. And so step back for a second and starting off. The first thing that's really super cool to note is nobody here really needs a definition of a spreadsheet. Obviously, everybody knows what a spreadsheet is. And that's one of the great things about targeting spreadsheets as an application platform is because obviously you know how to use it and other users know how to use it. However, one of the interesting things, if I asked every single person in this room to give me your definition of a spreadsheet and what are the use cases you use to build a spreadsheet, I'd hear a lot of the same things. I'd also hear an awful lot of different things. And that's really the magic behind a spreadsheet. The versatility of them really kind of makes them magical, which is why I prefer this definition of a spreadsheet. Now, little history flashback. Bob Frankston, when he was co-founder of VisiCalc, said, the definition of a spreadsheet is a magic sheet of paper that can perform calculations and recalculations. And it truly is magical. First of all, I want to make a shout out to VisiCalc. It's now 40 years old, founded in 1979, which, by the way, is probably older than a lot of folks in this room. Eric, I know it's older than you, right? But I actually used it when it was a brand new application. And it was the first time I really saw the power and the beauty and the magic of what a spreadsheet can do. And a couple things about a spreadsheet at that time was it was the first computer program that really wasn't just a top-down sequential way of doing processing, right? You didn't write instructions and the computer just executes them off in order. It allows you to put content anywhere within the spreadsheet and it updated it automatically. And that was kind of neat, right? You didn't have to be a programmer to learn how to write those instructions, which was the other really super cool thing about it. It really kind of democratized the way people could build solutions using a spreadsheet. Now, I remember, and again, I literally did use these on the Apple IIe that you see sitting here, which does kind of date myself. But I remember the first time I saw this, I was like, well, what am I going to do with this thing? And I remember I'm a super huge baseball fan, if anybody who knows me. And I used to keep all the statistics of all the different baseball stats. And every single game, I would log this on a piece of paper and do the hand calculations and erase the old calculations. And then I discovered VisiCalc, and the rest was history for me. I was able to go in and automatically make that work. And so that was my very first application a very long time ago. And as you can see, obviously, the rest is history. So since then, we've had past VisiCalc, we've had SuperCalc and Symphony and QuattroPro and Excel and Lotus 1-2-3. And now today, obviously with Sheets and Sheets as a service, this makes us one of the most ubiquitously, widely available platforms for building applications in the world. And that's the spreadsheet using something like Sheets. So obviously, it became a much better calculator than we had in years past, and that was really the prime use for it in the beginning, was how do we make a better calculator? But since then, as people do when they build solutions, is they find new ideas and new ways of using things. And I always say a spreadsheet has become kind of the Swiss Army knife of building applications. You can build a lot of different things with it. Commonly, you see people build database-based solutions in a spreadsheet. And sometimes we think it's a good idea. Sometimes we get very afraid of what people try to do with it. We kind of say misusing a spreadsheet as an application. But again, there's a lot of great features and functionalities in there. And of course, people do other things like analysis and ad hoc modeling and all kinds of different things. Probably the most common thing you see people do is use a spreadsheet for list management. Right? You come in, you got this nice 2D grid of data, you start typing things in there, whether you kick off a project or do something else. We do it all the time here.
Oh, yeah. You can see the history of my thought process by looking at the history of my spreadsheets, right? It's like a reflection of how I've approached work at work.
Absolutely. And so obviously a ton of other things you can do with it. And so that's why our argument today is spreadsheets make really good applications. And so you're like, what application? Sure, it's kind of a broad word. I think apps, I think, smartphone app or something, whatever. But really, when you think about what is an application, it's simply a piece of software designed for a specific use for a specific user or set of users, right? So it's simply to make it work. And so by that, I say a spreadsheet is a really good application platform. And again, if you're looking at it from a development standpoint, traditional multi-three-tier development, you've got the UI layer, you've got the logic layer, you've got the database layer, and a spreadsheet gives you all those things, right? I've got that 2D grid where I can quickly put in data by rows and columns, then I can sort and filter and make it pretty, which is kind of my UI layer. Then, of course, I've got a full logic layer where I can use not just the built-in functionality, but actually extend it and customize on my own using things like AppScript, which we'll talk a little bit about today. So it really is a great application platform. And that's why our argument today is that spreadsheets make a really good application, right? Really fast, easy to get started. I can go up to the formula bar and go sheets.new, and I'm already creating an application, an idea. How many times a day do you do something like that?
I lose count.
Absolutely. And so the other thing, just besides being fast and easy and accessible, is the fact that it's so feature-rich. A lot of folks are like, I want to build my own application my way. And my answer is always, if you think of all the built-in functionality in a spreadsheet, if you were to create the ability to store data, the ability to analyze data and format it, the ability to do things like pivot tables and charts, if you were to build all that plumbing and infrastructure yourself, you'd still be working on it. With a spreadsheet, you can be done with an application way often, way faster than anything else you can build on. And so for that reason, I think it makes a super great application. I think the other thing that I find very kind of special about spreadsheets is, unlike a lot of development paradigms where you have to go out and gather requirements and then go back and build a solution as a developer, then go back to the user and see if it works, spreadsheets can be built using teamwork. As easy as I can share a spreadsheet, right? Just like I share a file, I can go out and I can bring others involved in the process in, whether they're technical or not, and they can actually help me build my application, which again is very unique. And so it's very iterative, very trial, very bring the end user in who knows the business process likely as good as you do or maybe better, and you can come up with a better solution.
Yeah, and this is something we see at Google all the time. I mean, we've only just been speakers here at Next. We haven't organized the whole thing. The number of spreadsheets I've seen that powered this event is dizzying, right? Like, it was the right choice for building out a whole bunch of mini applications that make this come to life. And I feel like, especially as coming from a developer background, sometimes you get a bit of spreadsheet shaming, right? You send out a spreadsheet, people are like, really, another spreadsheet? It is the right choice for a large amount of problems. And I think, the points you highlighted here exactly double down on why that's the case.
However, we don't want to overemphasize and say you should build every type of spreadsheet application in the world you can, because there are some times where it doesn't make sense. Now, one of the things that we were talking about earlier before we came on was how great it is to use a spreadsheet where you can kind of use trial and error and see if the solution fits, right? You can know pretty quickly whether or not it's a good place to put a spreadsheet to build a solution, right? There's certain kind of tells that there is. Also, one of the neat things about it is you can use it for a while and actually kind of outgrow the boundaries of a spreadsheet, but get a lot of use out of it, and maybe not waste all that development time on an application that could stay right inside of a spreadsheet, right? So it's a great place to fit that in, which I think is kind of neat. So when does a spreadsheet not make a good application? Well, there's some kind of obvious things that you may see. For example, if you have a very extensive logic layer where there's a lot of complex functionality and you may need extensive UIs or a lot of hand-holding of the user or protection of the data, then that may not be a good place to put in a spreadsheet, right? You've probably seen this, Eric. And let me ask the folks in the room, how many people have ever seen a spreadsheet that just grew out of control? It went from mission critical to mission impossible. So nearly everybody in the room, hey, keep your hands off if you're the person that built that spreadsheet. Now also keep your hands up if you're sorry. Right? I mean, we see this quite a bit.
Well, I mean, the phrase I saw you have once in our notes, spreadsheets happen, right? Like, it just happened. And I think it's not a bad thing. The fact that you got to that point means that your idea was right. It was the right thing to build. The fact that everyone started using it and it grew out of control meant that it had value. So I think it's in a way, it's a sign of its popularity and its success that it grew to that point.
Absolutely, but don't overdo it. Don't create an application in a spreadsheet just because you can. For example, there's a lot of great third-party tools out there that I see people try to recreate in a spreadsheet. Just because you can create an expense reporting tool in a spreadsheet doesn't mean you should do it. You want to make a CRM in a spreadsheet? You could. Is that the best thing to do? Maybe not, right? So you have to figure out that buy versus build and do it. But the great thing, again, is spreadsheets let you evolve. It's really about the journey and the process of using how the tool allows you to iteratively create the best working prototype you can before you go somewhere else.
Yeah, this screenshot here is an example of one of the many spreadsheets that I've managed over time. It's the case that within Google, we have many, many teams working on many things simultaneously. It's just difficult to keep track who owns what, where is it in the life cycle, where are the different resources associated with it. And as part of developer relations, for me, it's APIs. What are all our APIs teams at? What's the latest release? Where are the docs? I built a spreadsheet for first my own purposes, then my team's purposes. Before I know it, actual product teams, PMs, they were coming to me looking for this information.
So I used this spreadsheet, and it was this wide. And by the way, for the folks not in the room, it was really wide. You went way out past Z.
Yeah, if you go past Z,
once you go past Z, you've gone too far.
It is a little bit too far. It was a time to hand it over. And luckily, I had proved out the concept. I had proved that this was data that needed to be captured. People found it valuable, but it was better maybe to move it to another platform. So there was a new team that was looking to kind of help organize all this information. So they took my spreadsheet as raw material, and they turned around and built an AppMaker app, which is the second screenshot. I had nothing to do with it. A few weeks later, it was live, running. We've used it ever since. It's a way better at kind of providing cross-link data. Obviously, you don't have to worry about people stamping over each other's information. The scrolling problem is gone. So this was a case where I don't think I could have skipped the spreadsheet step. That step of proving the idea, getting the raw material, was required to get to this destination. And that part of the journey is really what we're here to talk about today.
Awesome. Let's do it.
Yeah, so we're going to jump over now to a little bit of a live demo. And Charles, I do need you to sign in briefly. So we're going to talk about the life cycle of a spreadsheet, right? Now, this is not every spreadsheet goes through this exact path, but I'm hoping this is a little emblematic of how things are going to run. So you're starting a project. First thing you want to do, open your browser. And what I do, and what Charles mentioned, is sheets.new. If you don't use that entry point, it's a way you can actually, with just typing in your browser, create a brand new Google Sheet. So like I said, anytime I start a project, here I am in Google Sheets. So the hypothetical world we're going to be in here is one where you're approving requests from your team to travel for various reasons. So I have been doing it via email, and I'm getting tired of that. So I'm going to create a travel requests spreadsheet. Now I'm going to have a little helper on my side here leading us through this journey. But this stage of the life cycle, I'm calling the infancy, right? I have some kids of my own, and I've been thinking a lot of how children develop. So I see this as infants, where infants come out and they don't even know they have hands. They end up scratching their face because they don't even know the own boundaries of their ideas. And that's kind of what I see this as like, right? You have a blank slate, and you're trying to figure out what is in my head? What are the pieces of data that matter to me? How do I organize them? How do I think about the problem, right? And so in this case, I'm just throwing some initial data in here. I dump it into a sheet. This is like my V0, V-1, right? This is great, but not that great. The next phase I'm calling toddler, right? This is where it's all about confirming. I got a toddler right now. As I drive him to daycare every morning, it's all about car, truck, sign, tree. He repeats every single word because that's how he gets validation that he understands and is speaking the same common language as I am. And at this stage, this is where you're using the share button, as Charles mentioned earlier, to bring others into your development process, right? So you share it with others, and collaboratively, you help figure out, you missed some edge cases, you missed some boundaries when you were thinking about this problem. So in this case, I share it with some other managers who are doing a similar approval process, and you know what? We got to capture what state it's in. There are different cities with the same name. We got to have a start and end date to figure out how long they're traveling, and we got to break out the flight and hotel costs so we can get a better idea of are they spending the money on the right things, right? So Google Sheets has a long track record of collaboration, commenting, sharing. This is where that comes into play. But there's more phases to progress. The next I'm calling grade school, right? This is where your child learns how to sit up straight, follow directions, hold a pen. It's about kind of playing the part of being an adult even before you're all the way there. And for me, this is about putting on that kind of external face. So for me, formatting. I am a big spreadsheet formatting hardcore person. I do not like spreadsheets that even have extra columns I'm not using. And I actually wrote an add-on that does just that. So this for me is about, use your bold, use your frozen rows and headers, conditional formatting. I love doing the one where you highlight the whole row based upon just the yes or no here at the end. That gives me a really clear validation as I'm looking at the content. And then data validation, where you can add a drop-down so that helps give users signals about how to use this application, right? This UI isn't just surface level. It's not just because you like the looks of it. It is giving hints to users about what the data means and how to use the application. And those hints are important.
I can't agree more. When you see that, that just black and white spreadsheet with all these numbers on it, it really doesn't help the user understand what the meaning of the data is. And using some subtle color, I don't mean bright red, yellow, and green, which blares at you and blinks and does those crazy things, but making it look so I can draw that user's eye to something like you've got here, I think really helps a spreadsheet kind of pop.
Totally. At this point, I mean, this is where a lot of my spreadsheets stop, right? Part of this lifecycle idea is that you don't have to move all the way to the end all the time, right? This could be a very good spreadsheet for doing your job. This is what that earlier spreadsheet I had looked like a lot, just with a lot more data in it. But there is more room to kind of progress through this lifecycle. So the next phase I'm calling middle school here. In middle school, it's a little bit about realizing maybe your parents need to have some distance between you and your personal life, right? Maybe you start kind of keeping a private diary, right? It's about, not everyone needs access to all the same information. And so in this phase, it's really about thinking about access, right? So before, the nice thing about a spreadsheet is you can invite anyone in. The kind of bad side is it's very democratized. Everyone can see and modify everything, and that's not always the right way to go. So what we do here is we actually apply some data protection to our ranges, saying, that approved column, you shouldn't be able to enter a request and approve it at the same time. Let's send so that only the travel approvers group at our corporation can actually make that change. A simple thing, but one that kind of now takes this application and adds a richness around separating data. The other thing you can do is kind of use a private spreadsheet, right? So maybe you use this main spreadsheet for entering the requests and keeping track of what's going on, but if you use an import range, you can kind of suck in a copy of it, and then maybe here in the notes I'll list out why I denied a certain piece of travel, just so that I can kind of have it for a record without maybe exposing every piece of my inner thoughts to the people doing the requests. So once again, we're still staying in the world of spreadsheets. We haven't broken out, yet we're already adding complex things like access control into our application. The next phase I call high school. This is where you get your first job, you learn about how to check in and check out on time, how to work the register. It's about process. It's I call building out the process, right? Having everyone in a spreadsheet just kind of start adding rows and being on top of each other, maybe going back and modifying something they shouldn't before. That process is a little chaotic, and there's a lot of times where you really want to have a more streamlined process so that people are channeled into the right destination. So what we've done here is upgraded this spreadsheet to use Google Forms. Google Forms has long been a part of spreadsheets that's built right in, and it makes it so that we can now maybe unshare this spreadsheet with the whole organization and just the manager group, and then direct everyone who needs to make a request to the form. So I've got a little link here. So the same information we're capturing before, why are you going, where, is all captured in the form, and they just get this one view into the process. They don't have to see where everyone else on their team is traveling, who's been approved and who hasn't, further kind of separating out the different parties responsible. And you can see we even get timestamps. It's a bit of a nicer flow for users, and it just helps kind of, once again, narrow who can access what at what time. Kind of the last phase of this sheet's life cycle, I'm calling the college student, right? This is where you're really learning bringing in the professional aspects, but you still go home for break and sleep in your old bed. So you're still in the comfort of Sheets. You haven't left, but you really want to start bringing in app-like functionality that people come to expect. And this is where we turn to AppScript. As Charles mentioned before, AppScript is our cloud JavaScript scripting language baked deeply into G Suite, including Google Sheets, that allows you to add a whole lot of extra functionality that's not built into Sheets with relatively simple amount of programming. So what we're doing right now behind the scenes is creating a new app script attached to this spreadsheet that's going to add a whole bunch of extra functionality. So you can get to AppScript by going to Tools, Script Editor. It was there the whole time if you never tried it. And there's a lot going on in this AppScript, and we're not going to dig through every line of code. What I'm going to do is just run it to show you what the end result is. In total here, there's a little over 100 lines of code, and so you can actually accomplish a lot without a lot of coding. We use the same OAuth that you would use in any sort of fully built application to access your G Suite data. It's going through the exact same channels. Admins have the exact same visibility into data access. So as I tab back to the spreadsheet now, you'll see there's a brand new menu item up there called Travel Requests that is definitely not built into Sheets. With only a little code, I can add in my own custom UI elements. And if we're talking about guiding users to the right part of your application, there's nothing like custom UI to really point them in the right direction. In this case, I'm just showing a simple dialogue with some calculations. This is not interesting, but you can imagine all of the different extra companion functionality you could build in with dialogues and with sidebars and menu items. Now, that's interesting, but I think what's more interesting is doing things automatically, right? Having someone click a menu item is nice. I think the real savings come from when you take away a manual step. So what we're going to do is submit another request. This time we're headed off to Google I/O. And I submit that request, and it shows up here in the sheet. Now, before, maybe if I was the manager, I'd have to remember to come in and open the sheet every once in a while. But with AppScript, I can actually make it so that every time a new form entry is submitted, it takes an action. In this case, I'm having it send me an email with every time a new request has been sent. I can open it up, and in this case, I've created just a simple summary of what's been requested, as well as I can link right back into the sheet so that I can easily take action on it. There's way more ways you can get advanced here, but this is a simple way to get started.
So less than 100 lines of code, user doesn't do anything,
yeah.
And you create a workflow application.
Yeah, we're definitely getting into the realm of workflow right here. And not only that, once I am in that spreadsheet and I say, you know what, Google I/O, Eric, you are approved, I can also react to that change. So I've just changed a cell from blank to yes. And in this case, the person making the request and approving it is the same. It's me. But the requester can also get an email saying that their travel request was approved. This is like the kind of what this unlocks in your organization can be huge, right? The ability to kind of take all of that manual work, remembering, just takes it all off the table and builds it directly into AppScript. And then I'll just give one last AppScript demo here, which is that so you can extend the Google Sheets in other ways as well. So let's say I wanted to figure out, if they were going to drive to this location, like could they do it? Do they really need to fly? And so what I've added in here is a new custom function called driving distance. This is one that automatically knows where our office is located and then calculates how far it would take to drive there in miles. It's just like every other formula. You can copy and paste, you can drag down, and all of a sudden now I'm getting a whole bunch of contextual information that's built into this sheet and adds a lot more richness to the data.
Awesome.
So we're going to cut back to the slides now. That's kind of the life cycle up to here. But when you've reached that point, you've got a very functional application in a spreadsheet. But as Charles said, there's times when you'll even outgrow those bounds.
Yeah, absolutely. So you saw that application did feel like a full application, and I think it was a great job, and the effort was pretty limited. But what happens if maybe you realize that folks are in there trampling over the data, or the UI isn't intuitive enough, or you just simply want a streamlined application that is very specific to that solution so the user doesn't get lost, you don't have to write any documentation or worry about support. You want to make it just seem like it's a full-blown solution without the spreadsheet kind of in the way. So it's evolved to a point where you've got the business requirements down, you know it works well, then people like it, the app is still needed, why not build a full-blown app on top of it? Now, of course, you could go up and you can create a full-stack application, right? You can go out and start spinning Java code or Python code or whatever, build your own UIs and do all that stuff. But before you do all that, wouldn't it be nice if you had an interim step where you didn't have to go out and do all that full work? And maybe a lot of folks don't even have the ability as a developer to do that. Well, G Suite has an alternative, and it's a tool that's called AppMaker. A real just quick show of hands for folks in the room. How many folks have seen AppMaker already or understand AppMaker? So a good amount of folks have, so that's awesome. For those of you who don't, more than half, which is really good news. For those that don't, AppMaker is a Google's family member. It's a product that's available with Google Business Edition and Enterprise Edition, which allows you to quickly build a rapid application. And so the beauty of that is with a limited amount of code, which by the way is all based upon AppScript that Eric was talking about a second ago, you can go off and you can create that point solution using AppMaker. And so a couple things about it that make it real simple and easy. Instead of spending a lot of time going out and creating your own UI, you have the ability to come and drag and drop this user interface and not waste time fixing it all up. You can do it pretty quickly and uniquely. So I think that's one of the big things about it. You know what? Enough of me talking about it, since a lot of folks have already seen it. I'm going to flip over back to the thing and give you a quick show of how we take this application and we make it into an AppMaker app. All right, so when it gets up there. Okay, so picture this spreadsheet. Again, it's got a little more colorful. We've got some more data in it. It gets large, but you want to take it into AppMaker. One of the good things about this journey and the way these products work super well together is I can use this spreadsheet, both the logic of the data within it and the data itself to build my first application. So let's do that. So to get started, I can come in, and getting started is real super easy. I can say new, and if you come under here, you'll notice next to AppScript, in between sites, I can see AppMaker. So it's really easy to get started. It's built right into my environment. Of course, as long as it's been turned on inside of your environment by your administrator. If it has, you can come here real fast and simply say, appmaker.google.com if you want to do even a faster way to get there. and create a new project. Before you do, again, if you're new to the product, you'll notice there's a lot of ways to get started. There's some tutorials, code labs, even some great samples to actually use, and you can even put them into production or use them as a learning tool to get started. So let's create a brand new app from scratch. You'll notice there's a lot of templates out of the box. So you can see here a bunch of different templates that are available. There's even a neat one called Travel App Approval Already, where I'm going to show you at the end what it looks like if you use the template out of the box, but we're going to build ours from scratch and have a brand new application. Okay, so here it comes. It'll go off and it'll create a brand new solution for us. We see you've got the blank design surface. Let's come in here and name this thing Travel Request. We'll keep the same theme going. And the first thing I need to do is go out and bring my data in or create my data model. So I'm going to come in here and say Add Data Model. And you'll notice there's a few different ways I can do that. For example, I can bring in a Cloud SQL database or create one, which we'll do here in a second. But also I could use a calculated one where I could bring data in from other places and actually create it in memory and work with it there. As well as I also could bring in directory information. So if I want to work with my user profile data or stuff like that, I could do that as well too, which is great in a request application like this. But we'll just take the generic Cloud SQL version, and we'll name it Travel Requests. And instead of building it from scratch, we're going to say import fields, or I can go out and I can take that Google spreadsheet and select it from Drive. And you can see here's that colorful spreadsheet, pull it in, and notice it'll go out and look at the different sheets within there and offer me to build off of that model. So I can come in here and say, let's say next. It'll bring in all the fields. It'll bring in the column names for me and even the data types. And this is super neat. I don't have to go out and define my data in grave detail. I can come in and see the different data types. So when I actually do data validation or I use some of the controls and widgets available inside of AppMaker, they'll automatically come out based upon that data type as a preference. So we'll say create here. It'll go off and it'll create that first data model. And it's that simple to get started. Now notice I can do a bunch of other things with the data. For example, I can create views on it or relationships. I have a more complex data model, and it's kind of similar back in a spreadsheet where I would do either VLOOKUPs or use some validation handling on it. But again, I can build it all in here to my data model. I have the ability to add events as well as security. And this is kind of one of the things I think AppMaker does really, really well. We were talking about a spreadsheet, how people can trample over your code or your formulas or your data. Here I can make the models based upon user permissions and profiles. So, for example, in this case, I could have approvers only see certain data that obviously my users couldn't inside the model. So I can do that as well too. But other than that, my data model's done that quickly and that fast in this case. Okay, so the next thing I need is the user interface to take a look at it. So I can come in here and I can create a new page. There's one already stubbed in there for me, which I'll just say rename this, and we'll say add request. I say OK. And now I've got a blank design canvas up here where I can come in and just start adding widgets on top of it. So again, if you see all these different widgets in the panel here, I can put things like date boxes and star ratings and text controls and all these type of things in here. But one of the neat things is I can come in real quickly and add one without having to do a lot of work. I can create a form-based one and add it to my design surface. And just like this, I can choose my data source, say next, pick the type, in this case insert, and pick the fields I want out of that data model. I don't want the approved item on there. Obviously, again, I don't want people approving them either like you didn't. And then say finish, and there you go. That's how fast I can come up and I can build my first UI screen. And again, so far to date, I've written 0 lines of code getting this done, which is kind of neat. Now, one thing you'll notice, it's kind of a large design surface here. So what I'd like to do is also make this mobile ready. So it's really a good tool for building mobile-based applications as well. And I can have a little guidance up here where I can say, you know what, let's make this for larger phones, since most folks that I want to build this for have a large phone, and let's make it portrait, so they hold it this way when they're walking down the hall creating travel requests. And I can just manage it like that way and snap it to the grid. So you can see how the responsive design makes it kind of neat there. Where, again, I haven't done any work, but now I've got the beginnings of a mobile app. Okay, other things I can do. I've got a property window over here, which I can change any of these controls, do things like change the look and feel, change the names, etc. In this case, I want to make these buttons look a little more mobile-friendly and use our material design. So I'm going to take the submit button and the clear button, multi-select that, and apply those styles. So for example, I'm going to come in here and find something that looks a little better, a little more intuitive. Come down here. Oh, look, these are good. I'll use these fab ones. And also, I need to come in here and change that text on this one button because there's no submit material design name, but there is an add one. I'll put that in there. And real quickly, you can see, again, no code, but just one change. And I've got my form ready to go. So let's take a look at how this thing runs. Real fast, I can preview this. So again, another thing about app makers, it's really good for iterative design. I can come in here, see how the app works. I've got a preview mode. Once I go through my kind of required approvals here, which I only have to do the first time as the developer of this, you'll see I can come through and pick these real quick, get the authentication. And here in a second, I'll have a preview of my application. Okay, so this is the preview window where we've got a little debug tool available here. It kind of makes it smaller, but notice again, out of the box, I can come in here and say, you know what, let's put in a request for Charles. He's going to next, which is in London. And that start date, I believe it's sometime out in October. And you see we've got nice rich tools. And again, I haven't done anything to model these. It automatically picked the right type of ones based upon the format that it read when it built that data model. So again, next is going to end around there. And flight cost to London. So from here on the West Coast to London, kind of expensive. So I'm going to say that flight is a lot. And notice how it knew, again, because I'm looking for a number, it's automatically validated the data. So again, without even doing anything, I can make sure I get the right data in my application, which again, in a spreadsheet's kind of hard. People can put the wrong thing in. And unless you wrote a lot of code or did some validation rules around it, it's kind of hard. So in this case, I can just come up and say, you know what, flight's going to cost about $2,000, and it's probably about $2,500 for the hotel in London, and I add the record. So that's how fast you can start collecting data and building an app maker app. Let's quickly create a form that allows you to now do the approval process. So let's go back to the design surface. And I'm just going to create a new page. And again, a couple of different types I can create. The first is kind of a full page, but I also can do a page fragment, so I can reuse that across my entire application, as well as create some modal dialog boxes that pop up, which is kind of neat. In this case, I just want a full page. And I'll just call this approve. Request. And let's pick our data source again, so we don't have to do a lot of work, and all that binding will be done automatically behind the scenes. I say create. I'll come back over to my widgets. I'll pick that table, and I'll put it out there. Again, just take the default. I'll make it editable, but only for the approval, because I only want people to be able to approve this. There you go. And I've got a few other options about sorting or deleting and adding records in here, which I'll just accept all the defaults. And you'll notice I'm still on the big phone portrait. This is a little wide. I can either shrink it or go back to custom, where in this case I just want to make it wider. And bring that over. Got a little design surface issue here on this. Normally you're developing this on a larger screen, which makes it easier. I'm a little bit out of real estate. I don't know if I can grab the thumb and pull it over. And it's not letting me have it on the screen. We'll skip it for now because, oh, there, I got it a little bit better. Normally I'm on a bigger screen and it worked. I just couldn't get the thumb at the bottom. Exactly, shrink it from the other side. But the neat thing, if I could find that thumb, would actually shrink it and make it really easy to work with. Unfortunately, for some reason, I'm not getting that thing to pop up. Anyway, skip it for a second. Let's preview this and see what it looks like. Oh, wait, before I do that, I want to bring my data in. And you'll notice the data comes in separately on this thing. And, you know, I have a good idea here. Before I even bring the data in, let's make this so people can see the location of this user request. Remember I said earlier about making data very visual? The neat thing here is I can come through, and there's a lot of other widgets I can add. For example, if I wanted to add a location map, so I could see without having to read where someone's going. So if I see it somewhere far or luxurious, like Hawaii or something, I would know, and I could, you know, make a decision pretty quickly. So in this case, I'm going to come in, and what I need to do is simply bind up that map by saying, you know what, let's take the address and change its binding to the location of that data model. So as I scroll through those, I can see real quickly all of those. So I say, okay, and I need to get a key real quick for my data model. I have it here in my bookmark. There's a little copy and paste of my API key, so it'll actually run, and I can use that model. Now that, oh, I didn't bring the data in again. Let's try that one more time. I keep jumping the page here. So you recognize when you bring the data model in, it doesn't actually bring the data as well. It just helps you build the model. So you have to specifically come out here into the data settings and say, you know what, I want to import that data as well, too.
Yeah, I think it's often the case, actually, that you'll have even more than one spreadsheet, like copies and copies of spreadsheets used in different departments, you can actually now unify all those spreadsheets together into your data model, kind of bringing those separate processes into this one application.
Absolutely. So I can come in here, and I can say select that and bring it in, choose my model. It'll go out and look through Drive again. It'll take a second. There it is. We say select. We say import. And request. And I got a little error. Did I choose the wrong spreadsheet? Thank you. Did I? Let's try it again. Import again. And we authorize it. And that was my problem. That always happens. Okay, so I authenticate it and bring it in. And here comes my data. Fingers crossed. Okay, so there, perfect. Now we've got our 30 rows in here. Now if I go back and I run this and preview it, and pick that import form, you'll notice as I go through, all the data is in there. As I pick different ones, I can quickly see how the map updates. So again, I've got live bound data in my application and did very little once I realized I got the right sheet to bring into the data, so which is pretty neat. So pretty cool. And again, you saw how just for the few drag and drops and a couple clicks, I was able to bring a mini application in. If I was to fast forward and, for example, start working with a template, this is the built-in template of what it looks like. And you can see either starting with a template or with a little more effort, you can come in and you can build quite a bit of an application with very little effort. Now, people always say, is AppMaker a low code or no code or a lot of code, or what is it really? If you look at this application, you can see I've got a few data models. You can see how the data's been normalized. Like lodging and transportation is out. But again, pretty straightforward. You can see I've got a bunch of different pages, for example, that manage things like the requests and the dashboards. But to be honest, if you look at the code, you can see there's a little bit of code behind it. So for example, there's some client items that add a page request or approve the page, but it's not an awful lot of code. So I was kind of say it's kind of an in between. It's a middle code.
Yeah.
So it's kind of.
I think the code in this case is just it's letting you customize, right? Because what you built right there worked right out of the box. But like sometimes you need to continually customize, optimize. That's where the code comes in. I feel like it's more like an additive layer.
Absolutely. Layer. Okay. Cool. So that's AppMaker. Let's go back to the slides.
Sure. Looking at AppMaker, if I want to go back to my life cycle analogy, sure. I kind of think of it a little bit like renting an apartment, right? Like you can paint the walls, you can decorate, but at the end of the day, if the boiler breaks, that's not your problem, right? Like we're taking a lot of the hard parts around managing data, building models, building UIs, making sure they work on multiple browsers. Google is taking that kind of off your plate, allowing you to have a customized existence, but still a simple one.
Absolutely.
I think the last stage here is the homeowner, right? This is where, I want to buy the whole thing. If I want to tear out every wall, that's up to me. But also, if something goes wrong, it's also on me too, right? And that's when you really want to go beyond G Suite to build out your own top-to-bottom custom application. It's a great when you get to this point. Not every application gets to this point. Very many exist as spreadsheets or as AppMaker apps. But there are times when it's so mission critical, you want to have deeper integrations into internal systems that you need to kind of hand it over to IT or working coordination to build out something completely custom. And this is where the legacy, right? This is building something that lasts for a long time. The nice thing is if you've gone through that AppMaker stage, AppMaker is backed by Cloud SQL. So you can right away start working on that data. There's no importing it into another system or figuring out how to move it around. I think you could actually even have both applications, the AppMaker and maybe the new one you're working on, at the same time operate on the same data model, right? Because it's Cloud SQL, it's very easy to kind of share that data layer between where you came from and where you're going. The other thing I want to just kind of put out there is that users still like Sheets, right? Even if you kind of are evolving beyond a sheet, you're kind of making this thing production ready. Users still like working in Sheets. You don't have to actually give up on Sheets. I think what you can do is say Sheets is going to be a view into our application. It's going to be a subset. It's going to be a window into the data and process. And so, one of the tools that's in the toolbox here is the Google Sheets API. It allows you to, from your professional application, from Node, Java, .NET, you name it, take data and move it into and out of Sheets behind the scenes for users. These screenshots here come from one of our code labs we have up that say, like, look, you have a custom system, push data into Sheets for reporting, right? As Charles was saying, there's so many things you don't want to rebuild. It's not fun to rebuild charting. It's not fun to rebuild pivoting, right? Don't do that. Don't waste your time building out those Sheets features. Instead, think of Sheets as a reporting tool that you could instantly use for whatever application you've built, right? So take subsets of your data, views of your data, push it to Sheets, and then give it users in a form that they're familiar with, that they like to work with, that they know how to mash up, and kind of start that cycle all over again. If you want to get really advanced, you could even start using Sheets and the Sheets API as a bulk editing platform, right? As nice as your custom UI is, it's probably always designed with a edit, save, right? And a lot of times in certain use cases, people want to do bulk editing. Sheets is a great tool for that as well. Another way you can kind of stay relevant in Sheets is with an add-on. That sidebar that guided us through the lifecycle was a custom add-on I built in this demo domain called Lifecycle of a Spreadsheet. And you can do the exact same thing. You can have an internal application, and you can build a companion add-on that it kind of starts adding that relevant contextual information into Sheets, bringing in data, kicking off processes, kind of bridging the gap between that other URL that your users might forget and the Sheets that they are working in and day out.
Yeah. And I think it's one thing a lot of folks don't understand in the life cycle is, I've written a great application for my spreadsheet. How do I use it for other spreadsheets? And that's where the add-on comes in.
Yeah, the nice thing about an add-on is that although you can build one and distribute it to the whole world, which we have a large library of them, you can also just keep it within your organization. So you can make it that some custom functionality is now available instantaneously to anyone in your organization who opens up Sheets. And that can be a really powerful way to kind of not have to have a whole other discovery process for this capability. I'd also be remiss if I didn't give a shout out to Data Studio, kind of a close cousin of the G Suite family, one you've probably heard about here already a bit at Next. It's yet another very powerful way to take data that's in Sheets or in Cloud SQL, build visualizations, build charting. I've created some really nice dashboards in it that my whole team uses. And it's another way you can kind of take what is a process that's moved out of G Suite, but still kind of make it relevant using the tools that G Suite has. And then one more thing is just the G Suite Marketplace. I wanted to call this out that, although we talked about some tactics here today that you can use to grow spreadsheets into applications, we have a lot of great partners who are also building solutions in this space. The G Suite Marketplace is a great place to go to both find those kind of custom solutions for turning spreadsheets into applications, as well as some point solutions that Charles mentioned. There are a lot of times in which you may reach that point where your spreadsheet's grown too large, and maybe it's time to think about that buy versus build decision. And the G Suite Marketplace is a good place to discover apps that instantly work with G Suite, that connect up to users' identity and their data in a way that's pretty seamless. So let's recap a little bit of where we've been today. Spreadsheets, we think, are a great place to start. They're great for prototyping, incubating, validating, kind of showing that this idea that I have is worthy and right, and it has a purpose and a need within the organization.
Absolutely. And also you saw how we can do things like add forms and use AppScript to guide the user through a better experience by adding custom logic, functionality that we can use for getting input from them, and then taking workflow processes on top of that.
Yeah, and then I think AppMaker is a kind of a great pit stop on the road to kind of building your own fully custom application. It allows you to focus on the functionality and not so much the piping and the architecture. You get to add value immediately and then kind of not have to worry about some of those harder bits.
Yeah, and then finally, we recognize that even though your solution may not be centered in Sheets, Sheets are definitely a good component within your larger solution. So if you want to use that data or that ad hoc functionality, or like Eric mentioned, you don't want to recreate pivot tables and charts, build your solution somewhere else, but dump your data where your users really want it, back inside of Sheets, and let them work with it there. And you can use anything else in the GCP family to work with your Sheets.
That's right. So for learning more, a great place to start is our G Suite developer site at developers.google.com/G Suite. We have linked up there how to find more information about AppScript, add-ons, AppMaker, the marketplace, as well as we have a lot of getting started materials, code labs, quick starts, reference documentation, you name it.
So you got to remember it's developers.google.com/G Suite, and you get started.
That's it. So we want to thank everyone for coming. We would love and crave your feedback. So please, if you can, leave us a star rating. Tell us what you think. And thank you so much for coming.
Super cool. We got a few more minutes for questions if we want to take them.
Let's do it.
All right, let's take them. We got some mics. We got some hands up. You can come to the mic. That'd be super awesome.
Required that you talk into the mic, please.
So how do you distribute your app, right?
Yeah, how do you distribute?
Yeah.
Yeah, so for distributing apps, we talked a little bit about add-ons. With add-ons, there is a publication process, and you have to upload some images, specify some fields, but before you know it, it'll be just pop up in the store, the add-on store that's available within Sheets. So there's an add-ons menu that you can access, find more add-ons, and any sort of add-on available to your organization will show up there.
Yeah, so a key point is you can make it specific to your domain, or if you have an idea you want to share with the world, you can actually put it into the public store.
Yes.
So I use spreadsheets a lot for compliance, and so I'll have like the compliance requirement, the description of what that requirement is, how it links to other possible requirements and things like that. And that's not information necessarily that everybody needs, but then I find myself taking up like 6 or 7 rows or 6 or 7 columns of information just because I want it there. What's the best strategy if I were to turn like the sheet into an app to have the information available, but like not, it doesn't have to be like right there and not as messy?
Yeah, that is part of the problem with spreadsheets, is that it's this one view, right? The data, how you view the data and how you store it is kind of very tightly linked. So you can do tricks with hiding columns, but then that's the same for everyone, right? One of the features I like to play around with are filter views. I don't know if you use those, Charles, but it's the way to define preset views of your data that kind of can use filtering to hide things. And you can distribute links so that if someone opens a link that you created with a filter view, it'll jump them into your spreadsheet right away with that filter view applied. Now, it's not going to make that data inaccessible. They will still be able to see it if they get out of the filter view. So if it's about privacy, that's different. But if it's about decluttering, you can sometimes use filter views as a way to declutter the interface.
Thank you.
You're welcome.
Hey, great talk. Is there any plans to add any other backends other than Cloud SQL? For AppMaker in particular, because I was looking at doing a CRUD app for Firestore, and it would have been super handy, but it wasn't able to be done.
Yeah, I think one of the things you can leverage are the calculated models. So it's not first class. There won't be a radio, I don't think, anytime soon you can expect for Firestore, but that's great feedback. But as a bridge, a calculated model says, here's a model, and I will write code that does the actual population of the data. So you get a query specification, and then your code figures out how to transform that query into a result data set. So you're kind of building the glue layer that takes the model and the query and then makes the call out to whatever you want, any REST API that you need to get the data and then feed it back in again. It's a little more plumbing than you probably want, and I think we should look to adding more, especially Google first class data backends as options. I think that would make a lot of sense.
That'd be great. Okay, thanks.
Thank you.
Hi, I've been using Google Spreadsheets and whole G Suite. So I've been up to the level where I surpassed the capacity of Sheets. So I need definitely to go to AppMaker. One of the things I heard yesterday, basically, is Sheets is extending its capacity, and BigQuery, there's like 10 billion, right? Supporting 10 billion rows.
Yeah.
So that's a maybe workaround, like still using Google Sheets. I use like forms to insert data, and to end users, I don't present like the sheets. I present it in the Data Studio as a nice way. So there's like a app script that I use to when the forms is inserted and drops the added link through the dashboard on the Data Studio. So that's kind of a workflow. So
that's awesome.
Is there that like AppMaker is communicating to Sheets as a backend? Is there a possibility scripts to have that?
Yeah, go ahead, Charles.
Yeah. So currently you saw when I did the import and I brought the data in, that's obviously through the process. You could script that if you wanted to yourself as well. There's no like connector to do that per se. Like there's not a bi-directional back and forth, but you can definitely do that. In fact, Chris had mentioned, Chris Schalk is one of the folks who was on the team with AppMaker. He had something he wrote, and I think he's put in one of his demos as well too, where you could do it. So the bottom line is with the app script, you could actually write that and push that back and forth.
Yeah, and also one question, with the spreadsheets, there's a sidebar now, not the sidebar that you make in app scripts, a sidebar that's generic with I think like it's a Google.
Yeah, the side panel.
Yeah,
Yep.
side panel.
Yeah.
So there are three things. So are there any plans to extend it like a third party so I can maybe through app scripts put my
Yeah.
own app in it, like a sidebar app?
100%. Actually, yesterday, the PMs gave a wonderful talk about G Suite add-ons, the next evolution of our add-ons platform that is specifically about extending that side panel across all your applications, and Sheets is on the docket to be one of those applications.
Okay, thanks.
Thank you for great section. Do you have any plan for AppMaker to strengthen the connectivity with other GCP products like Cloud Functions or Kubernetes engines?
That's a great question. Yeah, I mean, obviously, G Suite and GCP, we want them to be a really seamless kind of experience where you can grow from these G Suite tools and kind of bring in more of those GCP services as you need them. I don't think we have anything on the short-term roadmap, but that's great feedback that you'd be looking for that. Obviously, a lot of times you can kind of build a bridge. Cloud Functions can be executed via an HTTP endpoint. AppMaker can make HTTP requests. So I think there's ways in the interim you can start to blend those yourself, but I think having it as be a radio button is probably a little ways off.
Yeah, and do remember all your data sitting in Cloud SQL, you can write that functionality on your own as well, obviously, too, so you can do it behind the scenes.
Thank you.
Okay. Sure, okay, we're going to take the last question right here in the back.
I often use AppScript to create drop-down in my Google Forms that then feeds the sheet, and it's bound to the sheet. If I take that sheet then and I move it into the AppMaker, will that drop down in that data verification piece that you showed, will that drop-down menu come with it, or do I have to write a separate AppScript for it?
That's a good question. Yeah, I don't recall offhand if that data validation drop-down, is that the one you're talking about, the yes-no?
Well, that was an example of one because I could write a drop list that goes in the form that binds it to that, but.
No, so you saw what I did was when I created it and looked at the example was the Boolean data type, so obviously it knew there was a yes-no already available. But if you had a y-n and you wanted that to be the answer, no, you'd actually have to put that property and put some script in yourself.
But you could write an app script for it, because oftentimes it's like choosing employee
Absolutely.
names, right?
Yeah. And you can create a table of all the conditional lookups you want to use as well, too, and use that with AppScript. A table inside of your AppMaker model. So.
Right. Thank you for the wonderful questions. We'll be hanging around outside after. Thanks again for coming.
Thanks, everybody.
Heating up, yeah, we're burning up, popping bottle tops.
let's get started, guys. My name is Sanjay Paranji, and I'm the CTO for Anadarko Petroleum Corporation. And I have here with me my engineering team who's going to talk about an IoT use case today. So let's start with a little bit of a macro view first and talk about why energy matters. And I want to give you a feel for who Anadarko is. We're an upstream oil and gas producer in the energy sector, but we want to talk about who Anadarko is. And we'll talk about some IoT-specific use cases, and then get into the engineering pipeline diagram and the build-out we did for capturing the use cases in GCP. So here's an interesting view of the world. When you think about oil and natural gas, building blocks for modern life, I don't know if you know this, but an interesting stat is 96% of all the products they use in a given day have some form of petroleum or petroleum derivatives in them. So it's a fairly ubiquitous commodity, so to speak. When you think about the global energy consumption, half the energy consumption in the world is oil and gas today. And that's a fairly important stat. And anywhere there's energy, there's almost immediately following that is human well-being and economic prosperity. So we take, with our company producing energy pretty seriously, and we do that in an environmentally responsible way. Last but not the least, is probably the most key statistic here, which is the global oil consumption. So if you look at the world and what we consume in a given day, we've got something like 100 million barrels consuming, consumption every day, which equates to something like 1,000 barrels a second. It's a fairly significant amount of consumption. And when we look at how this sort of forecast for demand grows over time, by 2040, the forecast is that we'll have grown the energy consumption by about 25%. And that's the demand out there that's been forecasted. And the question for the energy sector and oil and gas in particular is how do we keep up? And we feel like Anadarko is a part of that solution. And so we get to who's Anadarko. And I've got a couple of tidbits about the corporate portfolio here that give you a sense for who we are and where we produce oil and gas in the US and internationally. So when you look at West Texas, which is a cornerstone of the portfolio for us, we're an emerging giant. We attribute something like 4+ billion barrels of resources that we have to extract from underground over the next 4 or 5 decades. We have something like 10 to 20,000 locations we're going to drill over time in that play. And all that's enabled by a fair amount of technology going in. When we look at Mozambique, we're talking about one of the largest LNG projects. It's not online yet, but it's expected to be online by 2021 or 2022. We're going to extract something like 75 trillion cubic feet from underground there. And that'll be one of the largest LNG projects in the world, if not the largest. So we're part of both those areas, and we feel like that's how we keep up with the energy demand, and we feel like we're part of the energy solution in that regard. Going back to some of the softer stuff, we do invest a lot of money back in the communities and areas we operate in. And here I'm showing a stat that tells you that we've invested something like $2.6 billion back in the areas and communities that we operate in. And last but not the least, the group I lead, AIT, which is Advanced Analytics and Emerging Technologies, it's the R&D arm in the organization that's responsible for a lot of the technological underpinning of making all this stuff happen. So when we think about Anadarko in action and look at some of the digital solutions we're trying to formulate going forward to enable the portfolio that you saw before to work, we think of them as 3 block classifications. The first one is exploration, which is all about trying to find oil and gas accumulations across the globe. And that's a combination of deep domain expertise that we have in finding oil and gas, and also data mining. A combination of the two skill sets is what gets you exploration success. Development is the second broad category, and that's about extraction of the found oil and gas, the discovered oil and gas accumulations to surface. And that's about trying to find the most capital efficient way to do it, because we want to be a profitable company at the end of the day. And the most capital efficiency is dictated by how many wells you drill and complete to extract a certain amount of resource. And you want to do the minimum in capital expenditure and extract the most out of the ground. From an operations perspective, we deal a lot with real-time telemetry. Anadarko, for example, collects something like 3.6 to 4 million sensors that we have in the field, from all the way from drilling and completion sensors, which is rig operations, hydraulic fracturing operations, et cetera, all the way to the gathering and supporting infrastructure we need to separate crude oil from its byproducts and deliver it to market. So when you accumulate all the number of sensors we have in the field, we have something like 4 million sensors in the field that are doing something like a billion to billion point 5 updates a day because we're recording multiple points a day. We can now think about things like fleet performance concepts. So when you go to GE and look at aviation turbines, we can apply some of the same concepts looking across the entire fleet of assets in the oil and gas sector in the context of some of the operations we have, which includes construction of wells, which we call drilling and completions. So the use case we're going to talk about today is all about something called real-time drilling, which, as the name suggests, is about trying to beam IoT devices or putting IoT devices on drilling rigs, which, if you think about what a drilling rig does, it bores a hole through the ground. For those of you unfamiliar with the oil and gas sector, that's what we do. We just bore a hole through the ground, and you want to do it in the most efficient way. So oftentimes, when you do that, you have to track operational metrics like rate of penetration that you achieve, your drilling bit health, et cetera. And the more real-time telemetry you work with, the more sensory inputs you have to be able to assess the health of your operation. That's number one. The second construct is, just like you plot a course and a navigation course from going here to Oakland, we have the same exact problem. We are trying to drill a target down several miles below the surface, which is roughly 12 to 13 inches in diameter. So think of this as like a dinner plate. You're trying to hit a dinner plate several miles under the surface or under the ocean, and trying to do this with the surface controls on a rig. And if you have real-time telemetry, it allows you to plot a course and correct that course by measuring rate of deviations, rate of change between the planned well path, the planned path you proposed, versus what's actually happening as we sort of drill the well. So you try to measure rate of deviation and you course correct on the fly. And in the old days, that used to be an operation that was only possible retroactively. It was not possible in real-time mode. But now we can course correct within minutes and seconds when we find out we're off course. So that's the second construct. What we do here is we process electronic data recording data coming from drilling rigs, and we're able to stream that data in and look at operational KPIs and build predictive models on the back of that data. That's what we do. So the use case we're going to talk about is going to delve in some level of detail and really gets into the use case for what that looks like from a pipeline and engineering perspective in GCP, because it's natively built within GCP. That's sort of the beauty of it. So here's a quick demo. So what you see here is the dashboard. This is a business outcome we're striving for. This is in front of the drilling engineers and the asset teams, and they look at this on a daily basis. So what you're seeing is sliding time windows, and you're getting things like rate of penetration metrics, connection time metrics, tripping time metrics, et cetera. Tripping is the operation of connecting pipes. So we're able to not only look at various metrics and look at how we're performing our operation from a health perspective, but we're also able to understand and look across the entire fleet, which is the idea of trying to now position a well or a rig operation against other rigs that are operating at the same time, and look at the bell curve of the entire fleet at the same time, and also look at performance against previously known best performance. So you're able to see if you're within the guide rails of what you achieved before or you're off the rails. What this shows you is multiple wells and multiple rigs being plotted up at the same time. And all this is possible with real-time telemetry. So you're looking at real-time stacks of each well against each other. And you're doing that live and you're slicing and dicing it actively within the application we've got. But fundamentally, it's enabled by a lot of the aggregation that's done at the back end. So again, you can see at the bottom there on the right-hand side, the rate of penetration does vary quite a bit amongst the different wells. And that's a fairly important indicator for us to see how we're performing the operation. And I'll give you another snippet, last bit here, which is a 3D diagram that shows you the well path. And so what you're seeing is wells drilled off a single pad. You can see how complex it is and how tightly spaced the wells are. The idea here is that you're able to see the planned well path, which is in blue, and the actual well path, which is in red. We're able to see that against the offset wells in the same pad. And what you're doing there is you're trying to basically avoid collision risk between wells. And when you sort of zoom out and look at the complexity that we're dealing with, we're actually looking at wells from multiple pads now. You're able to see now how that well that you're drilling positions against all the offset well pads with just simple telemetry being beamed into the historian and then that being displayed into a web application, with a lot of predictive modeling being done on the back end. So with that, I'll turn it over to Eric Garcia, who heads up our cloud engineering department, and he works very closely with Google resources to make all this happen. Thank you.
Thanks, Sanjay. So we were working on a cloud-based blueprint to empower applications such as real-time drilling you just seen. Since we started our journey in implementing this blueprint in GCP, we've seen several key benefits, high scalability being one of them. Serverless components such as BigQuery, CMLE, and Dataflow proved highly scalable. This has let our developers focus more on the business logic and less on scheduling and scaling aspects. Another one we've seen is for the operations teams. A big benefit on having the operations teams be more smaller and nimble by using platform components such as GKE and Bigtable. Avoid a lot of low-level platform engineering skills in the team. Thus, they're more nimble to customer needs. Another big benefit was a reliable services. On average, we've seen about four nines of uptime per GCP component average. Insight Tool is the final one. Data Studio, Data Lab, Stackdriver has provided benefits to both ops and data scientists alike. All these help further accelerate our time to market for our applications. We decided to start on the cloud first. We used a lot of our existing data infrastructure in getting the data back, whether that was stuff that was housed internally or with partners. We wanted to do a quick POC to prove out the data engineering and model workflows and iterate through various approaches. This all sets the stage for having digital twins in our applications. This is kind of a grouping I came up with to describe the components, if you will. Some are open source, some are GCP native. I grouped them as data movement and stream processing, data at rest components making up our central data repository, orchestration and deployment tooling, app code and runtime environments, and then insight tooling for visibility, alerting, and development. Here is a high-level diagram showing our general data flow and ML processing pipeline flows. Not everything is depicted here, just the higher-level components. But this shows that we have several time series data sources that we're inputting. They're made up of external data service endpoints, vendors such as Calvin, who manage our edge deployments, also input and integrate data into GCP components and our tenant. A large part of our data also comes from our on-prem historians, such as OSI Pi. Getting data from OSI Pi, we had to develop custom near real-time data pipes to pull data into GCP. We also have Spark mechanisms to generate Parquet files to help the batch data for historical loads. Data flow is proven as a good data transformer and mover to places of rest, such as OpenTSDB and BigQuery. Cloud Composer drives our model training pipelines, which Composer is made up of Apache Airflow underneath. And then GKE kind of houses our inference models, our main applications, as well as some data engineering components such as OpenTSDB. Pleased to introduce Nick from Google PS team, who's been a good partner through our POC blueprint definition and implementation. Nick has a lot of oil and gas experience, and we'll dive a little deeper into the data components.
All right, well, thank you very much, Eric. And yes, as Eric said, my name is Nick Lozier. I'm a Google Cloud professional services consultant and been at Google just over a year. Spent about 10 years in the upstream oil and gas space. Prior to that, I focused on data analytics and actually had the opportunity to productionize a workflow quite similar to what Anadarko is doing here in the cloud. However, it was using on-premise Hadoop technology. So this project has been like great to talk about scaling this sort of like workflow on Google Cloud together. So with that, let's dive a little bit deeper into the data repository aspect of this IoT blueprint. There's 3 different components that we're using. There's Google Cloud Storage, Google Cloud BigQuery, and Google Cloud Bigtable. And for the folks in the room who are familiar with databases, you may wonder, why duplicate this time series IoT data in 2 different databases, including BigQuery, in addition to Bigtable. And I think the trend that we're looking up at the screen there is showing, the recent trends from dbengines.com, change in popularity of time series database. Really, it's like up and to the right. It's hockey sticking to the right. And the velocity is really kind of hard to track. And businesses like Anadarko, as we saw in like the real-time drilling application, want to enable real-time applications using that IoT. It's, the APIs that a time series database gives you is also critical, and that's why it's part of our solution. So how can a time series database be run on top of Google Cloud Platform? There's a couple different options, but what we'll talk about here is a solution that involves OpenTSDB and Cloud Bigtable. So OpenTSDB is a scalable open source solution that's really been around for a while. I think it's into version 2.4 at the moment. And as it says here, it's compatible with Apache HBase, Bigtable, and I think it's even compatible with Cassandra too. However, on GCP, you're using Bigtable, which is another fully managed solution, and it really makes the infrastructure, the maintenance, the setup, the overhead, pretty simple. And you're really just talking about like getting the data volumes in there to enable your analytics and real-time applications. It also includes a couple things that aren't included in a SQL API, including a REST API for query and input, this ability to downsample data. So, when you have extremely noisy time series points that might be at the millisecond level, and you want to kind of like smooth out the curve into maybe every 10 seconds, like OpenTSDB is really good at downsampling. And it also has this element of tags to provide filters on that time series data. I want to give a shout out to the Cloud Bigtable team, because on this project, they really helped us out. First of all, they published this solution on the Cloud blog that helped us stand up the whole solution quite easily. It really gives you the instructions. There's several GitHub links up there to the left. And another Cloud Bigtable member, his name's Solomon, actually helped us create the data flow pipeline to move the data into Bigtable very easily and seamlessly. So Solomon and Sammy, I just want to say thanks for all your help. So taking another look at data flow here, the architecture supports both batch loading in addition to streaming ingest of telemetry points. And Eric mentioned in his part that Anadarko uploaded over 100 billion time series points, historical points from a offshore platform. I think it covered maybe 3 to 5 years. They extracted this from on-prem, they put it into Parquet format, and they loaded it to Google Cloud Storage. And from there, the team had a very easy time loading that from GCS into BigQuery with a couple simple commands. And we were able to, I think in under an hour, have all 100 billion points pretty much ready to go right inside of BigQuery. After running a few quality control steps, we then moved the data from BQ downstream into Bigtable. We backfilled Bigtable. We'll actually see a pipeline demonstration in a few moments of how that part worked. Looking a bit further to the left, a very similar pattern exists for the streaming inserts. So we have batch, we have streaming. The only real change is we're using PubSub as our source instead. So Cloud Data Flow, which is a runtime for Apache Beam, really makes it very easy for nearly identical code to handle a very similar pipeline. And other architectures really require full rewrites to make this possible. So Beam was pretty strong here. One other thing I want to mention is we leveraged the new BigQuery storage API to pull that large amount of data from BigQuery and move it into Bigtable. Like I said, it was 100 billion points. It's quite a lot of data. And this new storage API basically lets you access the storage layer of BigQuery directly. So previously, when you extracted data from BQ, it would move out to GCS, and that process was a little bit time-consuming and expensive, not bad, but this is actually a lot more efficient. So we use the alpha version, and it actually just moved to beta. And you can see, like, Cloud Dataflow as a consumer on this slide, Dataproc, even third-party tools like Looker, Mixpanel, JDBC. So expect to see Dataflow process. So up here on the left, we're actually seeing the BigQuery storage I/O, and it's actually the alpha version. It's now beta, but it's basically pulling straight from that table that holds the 100 billion records. At this point, I think we'd already handled like 700 million rows in some 20 minutes. The subsequent steps are actually taking that data and preparing it to write directly into Cloud Bigtable. And we're using Java SDK for Dataflow here, and using the native OpenTSDB libraries to write directly to Bigtable. As we look down to the right here, we can see that Dataflow is using over 100 workers, or I think it's more like 100 like CPUs. It might have been like 20 to 30 workers. So it's scaling, a single pipeline across all these different machines in order to handle this really large backfill operation like extremely fast. Next, we're going to take a quick look here at the Bigtable monitoring statistics. For this backfill operation, we actually upscaled the cluster. I believe we used 130 Bigtable nodes. So it's actually, it's quite large, but it's only very temporary. We turn it up for maybe a day or two. We churn through those 100 billion events, get the time series database loaded, and then when we finish up, it's as simple as turning it down because the compute is detached from the storage. So really pretty convenient. Again, like we're not talking about standing up HBase clusters or VMs for any of this stuff. It's just really a few API like instructions via the UI. So pretty darn convenient. So to recap, I do think that IoT analytics truly benefit from having an API to the data, like for query, both from SQL, BigQuery, in addition to a time series interface, which OpenTSDB provides. Reading data at scale from a structured source, it's very easy and better to do now with the BigQuery Storage Read API. And finally, Apache Beam with Cloud Dataflow enables both historical and streaming pipelines to be performed with near identical code. So scale up on your Dataflow skills if you haven't. And with that, I'll go ahead and pass the presentation over to my colleague, Ryan, who worked on the ML part.
All right, thanks a lot, Nick. Hi, I'm Ryan Gillard. I'm a machine learning engineer at Google. And when I'm not helping customers create machine learning models and pipelines or doing research, I'm also working in the Advanced Solutions Lab where we have customers come on site and we teach them for about 4 weeks machine learning, TensorFlow, and how to integrate that all into GCP and take advantage of that power. So for this project, what we did, here's the IoT blueprint for machine learning you can see. We used several different services, which was a lot of fun because really got to see how they all interact with each other and take advantage of the scale of GCP. The main heart of it all was BigQuery. That's where most of our stuff came from, and then we would send that off to different jobs. All of the ML pipeline was orchestrated by Cloud Composer, where we set up different pipelines in a directed acyclic graph, or a DAG, which essentially just takes one process and then that calls the next process when it finishes, calls the next process. And you can have multiple branches and everything. It's really nice to tie all this together into a nice automated pipeline where you don't have to worry, don't have to manage it, it's all taken care of for you. For the actual 2 pipelines we made one for training and one for serving for inference. For the training, we pulled out of BigQuery, which came from OpenTSDB, and then we would train on that with Cloud ML Engine, and then we would send that off to our saved model with our saved weights and parameters for our model, and we would then use that in the serving pipeline, which will read those in as data comes in and be able to create the predictions and send them back to OpenTSDB in almost real time so that it can be plotted for visualizations right along with the true data. So it was really great, it's really fast, it was pretty cool how it turned out. So here's a little demo. So walking through the Composer, so it's all under the hood is Apache Airflow, but it's all managed by Composer, so it takes care of it for you. You can create different environments, check out the web server, look at logs, look at your DAGs, the code you have there. It's all Python files. You get a little dashboard like this. It's really nice. For this project, we had multiple DAGs. Each DAG did a different thing. We had a master DAG that called it all off. You can set up schedules. You can look at the owners, the recent tasks that happened, the last run, all the statuses of what happened. You can kick off a job right now, look at the tree view, the graph view, look at how your run times have been going, look at the code itself, refresh. A lot of cool stuff. Currently, we have it set up to do daily, but you can have KPIs that'll, you can have it metrics, say, hey, maybe we got to run a little bit sooner because this distribution changed. So right here, this is the master DAG. This is what kicks it all off. As you can see, it's pretty small. Essentially, we just get some of the training arguments and configurations so that we can send those off to the rest of the pipeline. And then right here, we call off our pre-processing DAG. As you can see, this is all just code under the hood. You create operators, Airflow operators, and those create tasks, and then you link them together downstream, upstream, et cetera, on what you need. All right, so here's the pre-processing. Let's change the view a little bit because it's a little bit big. All right, still got to zoom out a little bit. All right, so this was basically done with all BigQuery. I really love BigQuery. It's so great. It's super fast, super scalable, and we had Python operators that were creating dynamic SQL queries and sending them over. It's really good, cool stuff. So how we started to get our configurations, like our sequence lengths, our tags for our sensors, get all those in, then take our data, and then we're going to do a pivot operation on all that. From there, then we're going to create our actual data set. We're going to split it off into train, validation, and test sets. And from there, what we're going to have to do is say, hey, I need to know how to scale these things because machine learning works better when things are scaled. So I use my training set to figure out those scaling parameters, medians, standard deviations, and stuff. And then now that I have that, I save that in BigQuery and then use that with a simple join to then scale my 3 data sets. From there, I need to turn them into sequences because right now it's row, row, row. That's your time steps, but I need to get them into one element. Okay, so that I can do batching from a machine learning. So we use that, which is string aggregation in BigQuery over some windows. It's really nice. And then we just remove all of our files, if we have any, and then write them out to CSV and JSON, and then we call off our training job because our data is ready to go. So let's have a look at our training job. So let's change the view a little bit. All right, so here we go. We have to get our configurations again. Obviously, if I made a certain sequence length, when I made the data, I need to use that when I'm actually doing the training. So I need to get those arguments. I then check to see, do I have my data available? If I do, continue on, and then train on those sets. And then once I have a trained model, then I'll do batch predictions on my 3 sets, and then write those to disk. It's good to always do that in production ML to have those things so that you can have something to go look at and validate against anything that happens down the road. You have something to fall back on and say, oh, now I can reverse engineer this and maybe figure out what's going on. All right, so this is our deploy. So if you want to deploy to ML Engine, we just had a simple pipeline where we're checking to see, do I have a model? If the model is already there, don't overwrite it. Create a new one, a new container for that for our versions. If not, then can do one. Do the same with the versions. It's really nice with these branch Python operators. It's really cool how you can have multiple different paths within the DAG based on conditionals. And then from there, we have our batch predictions. Pretty simple. It's delete the old predictions, write new ones. And that is the training pipeline. All right? So a little recap. There's mainly just basically 6 steps. If you condense that all down, all those nodes. First, you got to read the data, obviously. You need to get it out of OpenTSDB. And then we're going to send that to our Heart, our BigQuery. That's where all that pre-processing is going to take place, all the pivoting, all the cleaning, all the filtering, and then turning it all into sequence data. Then, once you have the data done, obviously you want to train it. Okay, so then training it, taking that CSV files for training, send it off to Cloud ML Engine. It'll read it in batch by batch until we have a really nice trained model to do that predictions. It's essentially it's just an encoder, decoder, autoencoder for anomaly detection, trying to look at anomaly scores. And that way a person can then go and say, hey, this is looking to be anomalous. Perhaps we should intervene before the entire system collapses. And therefore you have a much reduced downtime. Once you have all that, like I said, you want to do batch predictions then on those 3 sets we made, so that way we can have some kind of validation against. And then we need to write all that back to GCS and then transfer it back to BigQuery, which then we're going to visualize from to see graphs and plots and all these other things to be able to check and say, okay, things are looking well. Oh, there's maybe an anomaly or something. We should go back and maybe retrain or something else. So that's the training pipeline. But we all know that the entire reason for machine learning is not to train and spin up computers and go through tons of data for nothing. It's all about prediction. That is the whole point of machine learning, is can I make really good predictions fast, okay, and at scale. So with this, we use Kubernetes. For this one, we have a bunch of Python code that is hosted in a Kubernetes cluster. We mainly did this so that we have an internal IP that was secure and everything. We read all of our data in batch format from OpenTSP directly. Then we had to do pre-processing. Obviously, you want to do the same pre-processing steps you did here as you did in training. Otherwise, you're going to end up with terrible training serving skew, and you're basically predicting from a different distribution than what you trained on. So same pre-processing pipeline. From there, we're going to do our predictions. So we're going to load our saved model that we saved out to Google Cloud Storage from the training process, load it into our Kubernetes memory, pass in our pre-processed data, and out we'll get our predictions. With those predictions now, I need to do some more with it. I need to post-process them and make sure they're separated, unpivoted, everything's ready to go, because I'm going to write that back. It's going to go to PubSub, and from there it's going to be feedback into OpenTSDB and to BigQuery through Dataflow jobs, and then it'll be plotted on our dashboards in almost real time. It's really fast. It's very, very fast. So that's how the inference pipeline looks. And with that, I'm going to hand it back to Eric to cover the rest. Thank you.
Thanks a lot, Ryan. Well, now that we have the time series data at rest and the model data also at rest, how do we get some insight into that? We found that we started using Grafana a lot for dashboarding in a couple ways. For data science inspection of individual tags, it's been really handy. Another way is also for data outage alerts, for more on the ops team side. Also, we have the near same capability with Data Studio for getting into that same model result data inside of BigQuery. As Ryan alluded to, Data Lab and the deep learning VMs, they provide a low ops Jupyter Lab-like environment for data science development, all respecting the GCP IAM security side. And then finally, Stackdriver has also been valuable in helping us monitor message queues to see when there's also data outages in those too. Most of our compute environments consist of GKE. We have basically per app namespaces created, sometimes per project. We have everything locked down via GCP IAM service accounts for deployment, as well as RBAC security applied. Our namespace quotas are also applied and pretty locked down, so we avoid any noisy neighbor issues. For some of our high I/O or high CPU workloads, we'll also cordon off on special node pools, sometimes GPU node pools, scaling back to 0 when needed. The traffic is directed through Nginx ingress controllers. They're fronted by GCP internal load balancers with wildcard DNS applied. The diagram you see here depicts pretty much what you saw Sanjay demo around the RTD application. It consists of a Angular single-page application backed by a Spring Boot Java application for the back end. Liveness and readiness probes are mandatory in our clusters, so we can monitor the health, and Kubernetes can restart anything that's deemed unhealthy. Also, the inference models, as Ryan mentioned, are also running in the same multi-tenant cluster. They're also taking advantage of horizontal pod auto-scaling. And then for our CI/CD tooling, we continuously deliver all the components from the inference side to the RTD app. Also, the runners are in GCE. In conclusion, and some future directions we have, we'd like to further our cloud automation with Git-based tooling such as Terraform and Spinnaker, which we've been looking at. More cloud service adoption. A lot of them have been announced this week. So anything from AI Hub to Cloud Run to Traffic Director for more of a managed Istio approach. And eventually this is all getting us towards the edge. We're looking at several IoT edge platforms so we can automate these retrained models, custom apps, and configurations. We're hiring, and any questions?
I have a question. As far as I understood, you're just collecting data right now from the sensors, analyzing it, and predicting. But how do you communicate back to the devices? How do you control, how do you improve drilling, for example, based on the data that you received? Is it done by human? Do they still make a decision? Or you have something automated that takes an analysis and performs?
You want to take that, Eric, or me? We are looking at control aspects. What you see now is an open loop control advisory system. It's not a closed loop system at all. We have plans to push it out to a point where we're able to insert those set points directly in the auto driller. And we're working with some rig providers to be able to do that. So we can talk more offline about this, but at this point in time, what you saw was an open loop system. It's not a closed loop control system yet.
My name is Nagesh. Thank you for a wonderful presentation. I run an enterprise IoT startup. My question is two-part. One is, what type of predictions did you have a priori before you started the journey? And what were the deviances you saw, or the deviations you saw based on the predictions from these models? Hopefully they have shown you more insights than your initial prediction.
Yeah. Want me to handle it? Okay. So the idea here is that we're looking at, there's sort of a BI component here, which is very basic, but the idea here is that you're looking at tripping time, rate of penetration metrics, and things of that nature. Where the prediction comes into play is you're trying to project control paths off the well in the next 10 or the next few hours, and project the well path based on trendology seen in the past few hours. That's where you get the rate of deviation between what you projected and what's actually happening, which then gives us insight to how to roll that back into more predictions going forward. So the whole premise is really based on the simple idea that you're trying to navigate the well path as close to the line as possible, and the more informed you are as to what the trajectory would be in the future, the better your course correction strategy would be. So it's not a reactive system, it actually tries to project what happens going forward. Hopefully that answers the question. I can get into more detail on that one, but I figure we can probably talk some more.
Hi, my name is Gary Engdahl. In my experience working with industrial data, it's very complex and you need a lot of context around it to truly understand it.
Yes.
You talked a lot about the time series data here. What are you doing to kind of link it with the other contextual data that's needed to make it truly understandable?
Yeah, I could talk a little bit on that. We're replicating some of our relational data from on-prem. A lot of it's alarm databases that would help, enrich the models.
Well, we're looking at, so we try to couple tubular data, well trajectory data, et cetera, so the real-time components that you saw was one piece of the pipeline, so which is what we call the EDR data from the rigs. And so you've got essentially WITSML or WITSOR protocols at the field level that sends data from the rig instrumentation back to you, either the Modbus or the PLC levels. And then we try to couple that with things like tubular or BHA assembly information that we have stored in our databases and try to couple those for contextual knowledge. So it's not just sort of time series data in a vacuum. We're trying to couple that with other data sources that we have on-prem.
Christopher Francisco, I'm also a startup CEO. And my question is more around data federation. And I know that at the rig there seems to be a big discussion around how do you allow both owner and operator, I believe, to leverage that data. So I'd like to hear about that. And I think you briefly touched on kind of the edge aspects of this. And just any thoughts on how you're seeing the future of kind of edge computing? I'm going to throw in containers because that's what I do, but anything in relationship to what that's moving towards.
I'll take the first one, which I think is, I think you're talking about a commercial framework and try to split the, sort of the liability, if you will, between the operator and the owner of the rig. Is that, did I capture the question correctly?
Correct.
Okay. That's a tough question to answer. It's not something that we've, there's not a framework established in the industry to be able to do that effectively at this point in time. But there are people experimenting with next generation rigs and trying to provide an open loop control system which you can interface with on an active basis. So we are looking at those sorts of providers to be able to interject new commercial frameworks, new business models where you sort of split the risk, if you will, between you and the rig owner, between the operator and the rig owner is what I meant to say. But that's not a situation where we have sort of worked out the answer yet. It's still a work in progress, I would say. The second question, which had to do with, I think, edge computation, that's a valid question because obviously you wanted to federate the learning across the entire fleet in your cloud, effectively, because that's where you've got the big massive data effectively from all of your operations over the last 1 year, 2 years, whatever it is that you've collected the data for. So you wanted to federate the learning in that aspect, sort of in the cloud environment, and then push that learning back out of the edge devices if you can, while doing inferences if you can at the edge. So we're looking at hardware providers in this case. The partner we work with is Kelvin. We're looking to insert edge TPU capabilities if we can at the edge, of course, and be able to do TF Lite type inferences at the edge if we can. That'll be on the roadmap for us, but again, we have to take it in a very step-by-step manner. If we validate and put enough mileage on the map with some of the open loop control systems we've got right now, then the drillers will tell us if we're on the right track or not. You have to get that validation step through. It's a bit like riding around with your car with sensors open, trying to gather the data and put the mileage in the cars, basically, before you take it out for a test ride for edge computation. We haven't crossed that bridge yet, but it is on the roadmap for us to do. But I would say that that's a combination of TF Lite type modules working at the edge, which is entirely possible to do from a technical perspective. But do we know the problem we're solving completely defined yet? And I would say that we're still in the early stages of figuring that out. But I think we've got a fairly good roadmap, I would say, for at least 2 use cases we've got pinned down where we can insert control points, control set points back in the PLCs that are outputs from our current analytical models, and we know where to plug them in from a control system perspective. The question is, can we actually execute on the program going forward, and do we have enough mileage, so to speak, on the open loop system, be able to call that 90% of the time or 95% of the time we're making the right calls from an optimization perspective to push out those set points back to the edge. We're not quite there yet.
No, that was great. Thank you so much.
You.
Looks like that's it. Yeah, thank you guys for coming.
Thank you all. Thank you. Appreciate it.